live, please. And then let's get the first question in the queue. Coming up from Millie. What do you got for me, Millie? Ooh, convergence. I like this. I feel like this doesn't converge already. Right? Just because the nth term is... The n plus 1 term doesn't go to 0. Can we just say that, like, already? Write out the few... Yeah, we'll write out some of the first few couple terms. All right, let me get the chats all working, though. One sec. It doesn't have to go to 0? To converge, it does. The infinity term has to go to 0 for sure. Oh, this is not a series. Oh. Ooh. Oopsies. You're right. I thought this was a series. Turns out it's a sequence. All right, let's write out some for n is greater than or equal to 1. Let's write out some terms. So if a1 equals 1, then the next term, so the next term would be the term before it. So that's 1 squared plus 2 over 2 times 1. So what's that? That's 3 over 2, so it's 3 halves. Generally, if it has a solution, it'll be an plus 1 is equal to an, but not always. What's up, JC? You had a stream this morning, yeah? I saw the notification on my Discord. I was asleep. I was up till 4 o'clock in the morning last night, so... And I think you went streaming at 7 a.m. my time. I guess I could have stayed up till 7. Running another 24-hour stream. I hope your stream went well. Oh, nice. Norowski's here. How's it going? Congrats, dude. Norowski got 2nd place in the math competition in Romania.
Yo.
What's up, dude?
Good job.
Congrats, dude, on 2nd place. That's fucking dope. Out of like 30 kids, right? Yeah. Wow.
Yeah.
What's up, Taco? Good to see you too. Norowski, do you have some fun series? So let me do this question, and do you want to teach us like a fun series thing?
Yeah, actually, I wanted to like comment on this.
Oh, please comment on this one.
Like, yeah. Yeah, I actually see a method using inequalities on this one. So if you want me to like write that out,
yes,
like I can
yes.
do that.
Do you want to like guide me? Do you want to like, kind of hold my hand, but like not hold my hand too much?
Sure, if you want.
Okay.
Like what I see.
Mm-hmm.
What I see here is we can actually use the AMGM inequality.
Okay. Arithmetic mean, geometric mean. Arithmetic mean, I think, is always greater than or equal to the geometric mean.
Yep.
Okay.
And the nth plus 1 term can be rewritten by like pulling out 1 over 2 as a factor, right?
Okay. So an plus 1 is equal to 1/2. And then do we want to say an plus 2 over an? Is that kind of what you wanted to say?
Yeah, exactly. Yeah. That's what I want to say. So this way, an plus 1 is going to be greater or equal to the square root of the product that is inside.
Okay. An plus 1 is equal to the square root of this squared. Is that what you're saying?
Well, no, it's going to be greater or equal to the square root of the product an times 2 over an, right?
Okay.
Do you see how?
Okay. Wait. An.
Yeah. No, times.
It's times. Yes. Because is this triangle inequality?
If you write it out, no, this is AMGM.
Oh, okay.
So if you an plus 1, you can see it is actually let me write out AMGM.
Okay.
So it's gonna be x plus y over 2.
X plus y all over 2. Or no, x plus y over 2. Gotcha. Yeah. This is the definition of the arithmetic mean. X plus y over 2 is greater than or equal to, and then you're going to say the square root of x times y?
Yeah.
Gotcha.
And you can see how an plus 1 is exactly that. It's 1 over 2. Yeah.
Yes. Oh, okay. Wait. So an plus 1 is 1/2. And then it's an. Oh, okay. I see what you're saying. These are my two terms, right? For x plus y.
Yep.
And this is greater than or equal to. Oh, this is beautiful. The elegance, Narosky, dude. The fucking elegance, dude. Yes, I get it. And this is greater than or equal to the product of an 2 over an. Oh, that's beautiful. Okay.
Yeah, and that's just the square root of 2.
Yeah, because it just cancels. Oh, wow.
Yep.
Oh, beautiful. Okay, wait. So this is an plus 1. So...
Yeah, so exactly. So any term is going to be greater or equal to square root of 2.
Okay.
Yeah.
Does that determine whether it converges, though?
Well, no. Now we have a bound, which is really nice. So all we can do now, right? If we manage to prove this is decreasing, then it's going to be the limit is going to be square root of 2.
Oh, I see. Oh, okay. So if we show
This
kind of
is
like
called,
by induction, I guess, that it keeps going down, then it has to hit square root of 2.
Either by induction or we just compare two consecutive terms, right? So if the difference between an plus 1 and an is less than 0, right? That means it is decreasing. Right?
Okay, but I think the issue is that the term's going up. Right? I think that's the issue. Well, I think so. Look, because if a1 is equal to 1, then an plus 1 is equal to 3 over 2, right? So that's going up. So actually, right?
Yeah. Okay.
Yeah.
I don't know.
This is beautiful, though. I think this is very cool. I like the AMGM came up. Yeah.
No, I actually think it's decreasing. I don't know how you got that it's increasing.
Really? I don't know. Well, okay. Well, look. Well.
1 second. So if a1 is 1, then.
So then a2, right, is equal to a1 squared plus 2 over 2a1. Is that not equal to 3 over 2?
Yeah. What was that? Okay, maybe it's decreasing after the second term.
Okay, maybe it's decreasing after that. Okay, that's fine. We can go check that. That's cool. I'm cool with that.
So if a3 is gonna be less, I think. I hope.
That's 9/4 plus 2 over 3, right? So, oh, that's kind of ugly. 17/12, which is less than 3/2. Okay. Okay, so it is decreasing.
Yes,
Well, I mean, after that term, it is, and we'll just assume it keeps decreasing. Okay. Okay, very cool.
We don't have to assume, right?
Is there a way for us to like algebraically or whatever calculusly prove that this sequence decreases?
Yes.
Without just like looking at terms.
Basic.
Okay.
Yeah, it's really simple. It's really simple. If we have the difference between two terms has to be less than 0. Do you agree with me?
I agree with that. As n goes to infinity, probably, right? So you're saying that, like, for instance,
So the right way to write this out is exactly that, right?
Yeah.
Less than or equal to 0 for all n greater or equal to 2. Do you know the symbol for all?
I don't know which one of these is it.
No. It's the v. Is the v? No.
Oh, it's this one. This one.
This one.
The anarchy symbol.
Greater or equal to, for all greater or equal to 2.
Okay.
Right. We have to prove that for all n greater or equal to 2.
Yeah.
So let's see what is an plus 1. We know the form for an plus 1.
Yes. So it's an squared plus 2 over 2an, and then we're saying minus an. Oh, I see what you're gonna do here, right, Narosky? You're gonna make this like an squared over 2an squared over an 2an, yeah?
Yep.
Okay. So then that's negative an squared plus 2 over 2an.
Yeah, so it's 2 minus an squared over 2an.
Okay. Got you. So negative an over 2 plus...
Wait. Factor that out, please.
What do you want me to factor out? The 2 or what? Or the n? Or like this?
So, do you know how a squared minus b squared is a minus b?
Oh, I see. You want me to flip this. You want me to do 2
Yeah, exactly.
minus an. Got you. 2 2an. And so that's 2 plus, or square root of 2, right? Square root of, oh, look at the square root of 2 coming up. Look at the square root of 2. Sneaky square root of 2.
Yeah, I think that was the point of it being square root of 2.
Ah, sneaky fucker.
See, and now how we know that every term is greater or equal to the square root of 2, so that product is actually negative because...
Oh, that's fucking beautiful. Oh, that's really
yeah,
cool.
we have square root of 2 minus an, and we know that an is greater equal to square root of 2.
Right, okay. So, at the best case, an is equal to the square root of 2, and then it's 0.
Which means it is constant.
It's constant, okay. Which, yes, that will happen, right? Yeah. Because eventually an will become the square root of 2. Okay. But for anything greater than it... Yeah. This is... Okay, so you can say, for all an greater than the square root of 2, this whole thing is less than or equal to 0.
Yeah.
Beautiful.
So we have proven that it is decreasing for all n greater or equal to 2.
Very cool.
Right? And now we have that it is bounded. It's greater than the square root of 2.
Yeah.
And it is decreasing, so there is a theorem. It's actually called Weierstrass's theorem. Do you know Weierstrass substitution?
I've heard this. Is this the one where it's like this weird fucking bee thing or something? You know what I'm talking about?
No, I don't know.
What is it? Oh, okay, Weierstrass. What do you like about it?
Yeah, Weierstrass. So this guy has proven that any sequence that is decreasing and bounded below, it's actually convergent. He has proven it.
Oh, that's cool.
Like formally. So if we want to just call on him, we can just say by his theorem, this is him.
It's the funny looking bee. It's the funny looking bee.
Yeah, it's that bee is actually double S in German.
Oh, okay. Okay, so since an is decreasing, 4 n is greater than or equal to 2, and bounded by being greater than or equal to the square root of 2, it is convergent. JC seems he seems not convinced. I seem convinced. I think this is cool. Makes sense to me.
It's not finished yet. We have only managed to prove it is convergent. We haven't actually shown that the square root of 2 is the limit. Is it asking?
No, I think it just asked. It did say find its limit. It said determine whether the sequence is convergent, which we said it was.
Yeah, we have.
And then and then, is this real now? Millie, what class is this, by the way? Some people in my TikTok chat are asking what level of math this is.
This is analysis. This is exactly what I'm doing in class. Yeah,
this is analysis.
Exactly what I'm doing.
Okay, this is analysis. Yeah. Kind of a tougher level math. Okay,
it's
cool.
Actually what I'm doing, so I hope I'm doing the right thing.
I don't know. We got the second place like Romanian math Olympiad champion, so I think we're okay. You know, I think you're doing the right thing. Okay, so how do we figure out what the limit is, though? We've proved it's convergent.
So we have proven it is convergent. So we are allowed to say that there is a number L, like so L from the limit, right? So there exists. Do you know the symbol for there exists?
Let me think. There exists. Oh yes, this is it. There exists.
Yeah. So there exists a number L. So L. There exists L.
L. Okay.
In the set of real numbers. So belongs to. Do you know the symbol for belongs to?
Like that.
Belongs to R exactly. Such that the limit of an. No. Such that.
This is not such that. Which one's such that again?
No. There is no. Just write.
Dude, there is a symbol for such that. No, there totally is a symbol. We found it.
Actually, there is. But I don't know it.
No, I'm gonna figure it out, dude, because I remember seeing that.
Okay.
It's the bar. Oh, it's the bar. Okay, it's the bar. Dude, I thought it was something else. Okay, fine. Whatever it's that. Okay, such that. Thanks, Paul.
Such that. This is confusing. So such that the limit as n goes to infinity
of an is equal to L.
Equal to L, exactly.
Yeah, an is equal to L.
Yeah, gotcha. This is the way you formally write this out. Okay, so there exists a limit equal to L. It is real, so it's a number. Now we are allowed to substitute L back into the recurrence relation, right? So we are allowed to use L because there is a theorem that says any subsequence has the limit of the original sequence, right? So any, hear me out for a second. So if you have the limit of an equal to L in this case, any n plus alpha, let's say any alpha real number, actually integer.
Okay.
This actually has the limit equal to L.
Okay.
Right. So this basically says that if we increase the increment by anything, we are allowed to say that it actually has the same limit. I think this makes sense.
I see. Okay. So you're saying, like, for instance, like an plus 5, like whatever, 5 or an plus like 10 should still go to L.
Yeah, an squared, an log n, whatever. Right? So
I see. Okay. Oh, so we can plug in whatever the fuck we want for n, and it should still go to L.
It should still, as long as it's an integer, yes.
Got you. Okay.
Yeah. So now if you look back into the recurrence relation, right? So the way we defined an.
Yeah, we said an was equal to an plus 1's. No. Sorry, we said an plus 1. An plus 1 was equal to an squared. Fuck. What was it?
Plus
was it
2.
Plus 1? Or was it plus 2?
Plus 2.
All over an. Yeah.
Yeah. So now we can just put L back into this equation, because if we take the limit of both sides, you're going to have L on the left-hand side and L on the right-hand side.
Yes, this should go to L, this should go to L. So then I say L is equal to
L squared.
Squared plus 2 over L.
Yeah.
Now, wait a minute. This is, okay. Wait a minute. But this is an squared. So shouldn't this, this is, okay, got you. Okay, we're good?
Yep.
Oh, okay, so then L squared equals L squared plus 2? Oh, okay. Wait, 0 equals 2.
Excuse me, 2, wait, actually 2L on the bottom. 2an.
Oh, it's 2an. Okay, good. I was getting worried there for a second. I was getting really worried. Okay, there you go.
Yeah. Now this works.
2L squared equals L squared plus 2. Okay, great. L squared equals 2. Now we have proven that L is equal to the square root of 2.
Yeah, and it actually we would have, if we did this from the start, we would have that it's equal to plus or minus the square root of 2. But because we have proven that
it's bounded on top by square root of 2. Got you. Yeah. Technically but like get rid of the minus.
Yeah.
Bounded.
Yeah. Because it's greater than 0 anyway.
Wow, that's beautiful.
Right?
Very cool.
So it cannot be negative.
Look at that. This is the way, dude. I like that. That's super cool.
Yeah.
Someone asked my chat, is he tutoring you? He's helping me for sure. I don't really know real analysis. And again, that's why I fucking love this stream, because like I'll help out kids with middle school, high school, whatever, calculus. I can do that like in my sleep. And then someone like Millie will ask me some advanced like real analysis question. And then someone awesome like Narosky will come in and help me. And then I get to learn. Wow.
Good job.
Fucking dope.
Whenever you do like calculus, I always sit and listen, because I don't really know calculus that much.
Oh, okay, cool. I'm happy to teach you calculus. You teach me this, dude. We're great. This is very cool.
I'll be doing calculus next year.
That's so funny. But how do you know real analysis if you haven't taken calculus? It seems like out of order.
Well, you don't really need calculus for real analysis. You most likely need real analysis for calculus.
Fascinating.
Right, because if you don't understand basic concepts in analysis, you cannot understand calculus.
It's so funny because in the American system, this is totally skipped over. Like I would say maybe 1% of college students know real analysis.
That's so ridiculous.
Yeah, we do not learn. This is like too fundamental. We just jump straight into calculus.
I mean, yeah, but if you don't know the fundamentals, how are you gonna know calculus?
You know what it's like? It's akin to we're teaching people how to drive a car, but we're not teaching them manual.
Yeah, exactly.
You know, one could argue that like if you don't, you just learn how like the gas pedal and the brake pedal works, but you actually don't know how the shifting works. That's being done by the computer. Yeah. Oh. Lincoln says, I'm doing integrals, but I just remember the process. Is that bad? It's not bad. No. Nothing is bad. The fact that you can do things even mechanically is still good. But I think what Narosky is bringing up here, which I appreciate, is that you have a better, more complete understanding and appreciation for the math if you understand what's under the hood. Like, how is this working? Super fucking cool.
There is a real accent put on, like, if you don't know how things are working, it's gonna be very hard for you to learn, like, the formulas and stuff, because you're not gonna be able to remember them if you can't derive them yourself, right?
Yes.
So if you can't, let's say you're in a competition, right, or in an exam, not just a competition.
Yeah, not everyone here is doing math competitions, but yes.
Yeah, let's say you're in an exam, right? And it's you come across some difficult problems. If you can't come up with your own solution to them or with your own formulas for them, like, what's the point of plugging in things you have memorized and gone over and over, right? Like, if you forget something, you're just you don't have another way to do it.
Yeah. If you're just memorizing things without applying them or understanding why you're memorizing them, you're less likely to remember them. Yeah, it's just yeah. I totally agree. I think the problem is that, like, we just don't have enough time teaching math in America and stuff, that if we had to teach people real analysis, we'd be fucked.
Yeah.
It's like people asking things in the chat. Someone else said,
how do I know how to do the unit circle? Wait, who was that on my TikTok? Oh, any tips on memorizing the unit circle? Yes, it's one of my first TikToks, Carter. If you go to here, it's one of my first videos. Go all the way down.
here's a cool way to remember sine, cosine, and tangent.
I talk about how to do, like, sine and cosine and tangent. I talk about how you can memorize the unit circle with only knowing 2 triangles. You only need to know 2 triangles, and you can do all of the unit circle. Like, fuck memorizing that whole thing. That whole thing sucks.
Yeah, really.
But this is also what Narosky talks about.
Like, if you understand where the unit circle comes from, right, and it comes from those identity triangle things, then instead of memorizing, God, what is it, like 36 different numbers, you just have to memorize 6, or really like 5 numbers.
Yeah.
Because 2 of the sides repeat on the triangles. Or actually, and sorry, the other ones are 1. So really, you only gotta remember, you only gotta memorize like 4 numbers. And then you can rederive everything on the fly, and it's great.
Yeah, exactly.
Yes. That's a trapezoid rule. Yes. Why do graphs for absolute value inequalities can't both be equal or 0? A10 or equal to 0. You're struggling with the pi part? Okay, if you're struggling with the pi part, Carter, then yes, definitely go to my TikTok and look at the one I talk about, like 180, right? Because that's at pi. And then the 270 is also like the 3 pi over 2. That's another one. I know. You get confused, like, which one's 0, which one's -1. Can I skip through my videos in TikTok? It's fucking annoying. Anyways, if it goes ahead, I basically show you that, like, as you get closer and closer to pi, which is 180 degrees, your opposite goes down to 0, and your adjacent approaches the hypotenuse. And that's how you can memorize that. Like, here's like the video of it. Yeah. Like, the red there is the opposite, and that goes from, like, as you get closer and closer to 180 degrees, the opposite drops down to basically 0. The adjacent, which is the blue, becomes as long as the hypotenuse, because the hypotenuse is the radius of the circle. So that's why sine, for instance, of 180 degrees is 0, because it's 0 over 1. Cosine is 1 over 1, and then tangent is 0 as well. Yeah. Cool. Nice. All right. Was that number theory we did earlier? No, this was real analysis. Narosky really helped us out here with a real analysis question. Millie says we do. Millie, where do you live? Where do you learn manual? I asked in my class that I was teaching at UCLA, I asked my 200 students to raise their hand if they knew how to drive stick. Only 2 people raised their hand. I'm like, what? I know how to drive stick. You don't know how to drive if you don't know how to drive stick. You know how to drive a golf cart. All right, how many questions do we have queued up? A lot. We do have a lot. Okay. Narosky, can I work through some of these questions on the queue? And then I appreciate you showing me that one. That was great. And if any of these other ones come up that you want to, like, hop in and, like, show me a much more elegant way to do instead of my ugly brute force American math, I'm happy to have you just yell at me. Just be like, no, dog. No. Like, there's a much better way to do this one.
Okay, I'll do my best.
Okay, appreciate it. All right. Let me download this one for Millie. This is a really beautiful proof. I really like this. And I learned something from this. I learned how important, like, AM, GM just comes up all the time, I guess. Especially in real analysis, right?
Yeah.
Yeah. What's the other one? So AM beats out everything, right? Because the other one you said was like quadratic mean?
Yeah, it beats out AM.
Oh, QM beats out everything. Is there a quintic M?
Well, no, I don't think so. But there is a generalization of this, but it's difficult to understand.
Okay. We'll get there. Baby steps. All right. Let me add this one to the. Where's my queue? There it is. Millie's question's done. We're gonna put that into the homework help channel. So again, if you're just watching us right now, website actualofficehours.com. If you go to this website, you can type in whatever username you want me to call you, drop in a screenshot, hit upload. It'll get sent to us, and we'll do it live here on the stream. You can always see what questions are already in the queue by clicking on live queue. And then this is where there is so far. Every time I do a question, such as this one right here, I'm going to save the solution. And then what happens is it'll actually go into our Discord. So if you join our Discord, you get to have access to all the questions we do and all the solutions we do. So if I just drag this in there, so here's Millie's question that just came up, and then I'm going to drag it in. Is FNet, depends if it's in component form or total form, Clash Dan. If they're asking for the magnitude of FNet, you have to do the Pythagorean triangle thing to figure out the hypotenuse of F. Triangles even in the unit circle, Pythagoras would be ecstatic. Yeah, he's a cool guy. All right, let's see what we got next. El Jefe, what do you got for me? Okay. This is something with Fourier transforms. I don't know if I can do this, but we'll try. I want to approximate a periodic function using sine and cosine functions, but the number of periods of my function over its range is not necessarily a natural number. So I can't use fast Fourier transforms directly. Oh, because it's not quantized. Okay. How do I find the number of fractional periods for a given function over a given range? I don't know. Norowski, do you know how to do this? I don't think I know. I don't know how to do this. What is this?
I don't know. I don't know what this is asking.
Well, so okay, so this is saying if you have any sort of function, do you know how a Fourier transform works? That's a good question first.
No.
Maybe I can teach you something. Yeah. Okay. If you have something, for instance, that's periodic, so in like signal analysis, a lot of times you have like saw waves, stuff like this. Yeah. This is periodic, right? This can be written as like a superposition of a bunch of sine waves. So it's like, I forget what it is.
Oh, I see.
Right. It's sine like n pi x over L. There's some other fucking shit here, and it's like n equals 1 to infinity. So like if you write out like a bunch of different sine waves with different frequencies, and also I think different periods, right? Yeah, and then there's a shift. There's a shift as well. Sorry. Yeah, plus like phi or something, or phi n or something. Yes. Then you can write a periodic function as a bunch of sums of sine waves.
Because their amplitudes will actually just converge at something like that. No.
Yes.
Because yeah.
Yes. Okay.
I think I understand. Yeah.
Yeah, you understand how it works. Yeah. Didn't you see the name of the text file? Is this fucking Jeff fucking with me again?
This is Jeff, actually.
Jeff, are you fucking with me? Dr. Gold sucks.txt. Stop.
Surprise,
I wasn't
motherfucker.
gonna say anything, but
Jeff. All right, Jeff, I love you. I don't know how to do this, Jeff. Okay, cool. But I at least got to show Norowski what a Fourier transform is. It's a real question. It's a real question I can't answer, unfortunately. So, I love you, but let me try to get through more of the queue, and then I can cut it. Oh, you were discussing it with physics and depression? Yeah. Okay, Mira says he needs help. Mira, submit a screenshot. I'll help you out. He was on last night. Yeah, I saw him. I was out at some Christmas party. I was like, oh, physics and depression's on. Maybe just hi to him. Oh, of course, El Jefe. Yeah, the name. I should get this more often. So Mira, if you want help, no, you can't join the live stream because like that goes through OBS. Submit a screenshot to that website, actualofficehours.com. You can submit a screenshot of your chem question, and I'll go through it. Actually, we need more chemistry questions. If you submit a chem question right now, I'll let you skip the queue. ChatGPT will work its magic, maybe. Okay, here we go. This is a fun one. Dude, I've been doing so much Calc 3 recently. All right.
Okay, what is this? This is
Calc 3,
right?
This is Calc 3, yeah. It's anytime you see like multiple integrals, it's like instantly Calc 3.
Isn't this a Jacobian?
It is. It is gonna be a Jacobian. Yep. Evaluate the integral where R is a region bounded by xy equals 1, xy equals 9, y equals x, and y equals 4x using the transformation x equals uv. Y equals uv to write the integral in terms of u and v. Yeah. So I'm gonna compute the Jacobian because this is, so for instance, this is dA in Cartesian. That does mean double integral IKEA. Yep, this means we're going to integrate. So we would integrate over dx, and then we'd integrate over dy. So if you had, I don't know, something that looks like this, you would like integrate with respect to dx, and then you'd also integrate with respect to dy. And then the function can be thought of as like something pointing out of the page. So like you're adding up all the towers inside like a region. It's very powerful. This is the Jacobian, right? So dA in Cartesian, so the area, the surface area element in Cartesian is equal to dx times dy. That's how we figure out the area in normal xy space. When I transform to some other coordinates, now what I need to do is I need to do things in like du dv, okay? But then the question is, wait, how does the area scale, right? How does dx dy map to du dv? And the way we do that is we say, okay, this is the same thing as, I believe, let me think how this is. Yes, this is like, it's like xu, yes, xu cross xv. No, wait, one second, let me think. Okay, here we go. So R used to be equal to xy. Now R is equal to u over v, comma uv. And so the Jacobian is like ru cross rv. This is it. Yeah. Right, yeah, the integral is the height above the xy plane. Yeah, exactly. Yes, yeah. So, sorry, this is dr du is what I should be saying. Sorry, dr du cross dr dv. Okay. Because in regular space, let's say for instance R was just equal to like xy. Then this would be like dx cross dy, which is just 1 cross 1. And then that ends up being, so that is the area transformation from dx dy to dx dy. It's just 1. This will give me some value that converts dx dy to du dv. And I think we also think about this because if you have like this, right, because this is what this is. This is like dr du, right? This is dr dv, yeah. And this kind of like maps out like an area, right? The cross product of these two things maps out the area of a trapezoid, right? Or it's a parallelepiped. What's it called? No,
I think it's going to be a rectangle.
I think it's a, yeah. So if they're perpendicular to each other, so if these vectors are perpendicular to each other, then yes, it just becomes a square or a rectangle. But I think this comes out to be, I think it's a parallelepiped maybe. One sec.
You're thinking of a parallelogram.
Yes. Yeah. Okay. Yeah. Wait. Cross product is area. Yes. Area of a parallelogram. Yeah. This is the way to think of it. Yes. This is what I'm thinking about.
Yep.
Yeah. Right, exactly. So that's what we're doing, is we're mapping out what like the new area dx dy is in du dv land. Yes, it's a parallelogram. Yeah, cool. All right, awesome. Okay, so and this is also the same thing as the Jacobian. Yeah, parallel pipe is a 3D shape. Thank you, Benzen. Okay, so this is the transformation. R is now going to u over v, comma uv instead of xy. So I need to calculate dr du. So dr du is equal to 1 over v, comma, what is that? Just v. And then dr dv is equal to u, comma u. Nice. Okay. And then we do the cross product of these things, I think. Yeah. Which is the determinant. For a 2x2, I think it's just the determinant of these two things. Oh, because it's the magnitude of it as well. Oh, actually, okay. I think I remember how this works. Technically, this would be in 3D. This is where it usually comes up. Because usually we do this for taking, sorry, something that's like spherical in nature, and we compress it down to like a circular, just 2D shape. But okay, in this case, dr du, which is this, that's 1 over v, v0. And then this is going to be dr dv, just u. Yeah, this is u, and then there's 0 component. So doing the cross product of this, right? So if I do the determinant of this gets me 0. This also gets me 0. So you're left with just this, which, yeah, is the determinant of a 2x2. And so that's going to be equal to u over v, minus uv. Great. It's the same thing then, is it? No? This is such a funny transformation matrix. Okay, cool. Yeah. The first one is wrong of ddv. ddv is u, no? Because it's u over v. Oh, yes, you are so right. You are so right. Thank you. Thank you, BK. Yep. I can't do derivatives today.
You done messed up,
yeah, it's fucked up. Yeah. I was getting too happy and confident with my work, honestly. I make mistakes. It's okay. Yes. Thank you, Francesco. Yes. I was looking at this. I'm like, bro, this can't be just the same fucking thing. Okay. Then let's be a little bit slower. This is right? I think we're still good. Yes. DDU. Yes. This is Calc 3 is what this is. Or multivariable is what we say. Okay, negative u over v squared. Okay, so now when I multiply that, I get uv plus uv over v squared. Yeah. Okay. uv over v squared. Cool. Okay. So then this is now my Jacobian. Because that's the only component that survives, and so the magnitude of that is just that component. So actually we can just write this as, this is u over v plus u over v. Oh, this is just 2u over v. Nice. That's actually dope.
Nice.
Okay. So this right here, so 2u over v du dv is the same thing as our dx dy. That's what that turned into.
So so the matrix actually just is actually acting like a geometrical
transformation.
Transformation. Right?
Yeah, or it's like a map. I guess we call it like a map, maybe, or something. I don't know. It's a factor.
Yeah.
It's the same reason that, for instance, when you do this in 3D, so if you do dx, dy, dz, this will map out to r squared sine phi dr d theta d phi. And this is how you map Cartesian to spherical. And it's the same technique. Yes, just be able to express in another basis. Yeah, brutal. Yes. So oof is correct. Yes, you are correct that this is all technically in the z hat direction, but the Jacobian is the magnitude of the cross product. So I don't care about the direction. So technically there was 0 in the x hat plus 0 in the y hat plus this in the z hat, and then the magnitude of that is just the z component. What's my background? I have a PhD in physics. That's my background. Okay, cool. Yeah. So I've only recently actually like understood this. Again, I've been teaching math for probably 15, 16 years. And it's only been like this year because of the overwhelming number of Calc 3 questions I get on the stream in the last couple weeks that I really like. I fucking understand this now. I'm like, oh, this is so cool. It's okay, Ray. It's okay, Ray. Wait, unless is this your question, Ray? I don't think this is your question, right? Okay. Okay. So now...
we just substitute?
Yes. Now we just substitute. Exactly. Right? So, and then what was it? I just need to write these, bring these down. Calc 3 is 100% harder than Calc 2. Yeah, like, it took me years to understand Calc 3, but maybe I just had a bad teacher for it. Just be confident, bro. Brutal. Yeah, just do it. Okay, so x is u over v, so this is the square root of uv over u over v, so that's going to be divided by u times v, right? And then plus the square root of xy, so that's u over v times uv. And so let's see, I hate to use u and v's. U and v's look all the same. Anyways, all right, this cancels. Square root of v squared is just v. And then this is, oh wow, so it's v squared plus u squared. Yeah? Stokes and divergence. If you submit one, I'll do one. You got to submit a screenshot. Yeah, I'm not gonna just like rant.
Why is it u squared? Doesn't the
so
square
you?
Go away?
Oh yes, thank you. Thank you, Dronsky. Keep me honest.
No problem.
Thank you, Benson too. Yeah, keep me honest. Y'all are paying attention. This is where like some professors would be like, "Oh, that's just a trick to make sure you guys know what's going on." Gotta do that on purpose. Okay, here we go. And then remember, this is now our dx dy. This is Calc 3. Calc 3, Rain. Ray, what type of math are you in? Like, I apologize if this is like really difficult. Just look at it. It'll make sense at some point. Okay, here's our bounds though. This is fucking weird, right? Just ascend. Brutal. Okay. Because now we need bounds on things, unfortunately, right? I need to know like where u goes from, and I need to know where v goes from. So maybe if we substitute this stuff in for here, that'll make more sense. So x times y is just equal to u squared, right? So that means it goes from u squared equals 1 to u squared equals 9. Do you have to... Oh, you're doing pre-calc? Yeah, so this is going to be... This is way over, but don't worry. This is a spoiler. This is what you'll eventually do once you get out of pre-calc. Okay, so u squared goes from 1 to 9. Y equals x. Okay, so what is that? uv equals u over v. So from v squared equals 1. And then y equals 4x. So that's uv equals 4u over v. V squared equals 4. Spoilers! Okay. This is where, I think we have to maybe put some restrictions on things. Like, x and y, either because of this, right, the square root, x and y both have to be positive or they both have to be negative. So let's think about what the restriction that puts on u, right? Because technically u can go from, like, plus or minus 1. But I don't think u can be negative. Or
well,
can
no,
it?
Because u is greater than 0, no?
U is greater than 0. Where do we get the u is greater? Oh, for here. Did we say that though? I don't think so. Why does U have to be greater than 0, Narosky?
I don't know. I just said. I believe it must be. Otherwise.
Well, X can't be equal to 0 because of this. I know that for sure.
Well, actually, it has to be greater than 0 because it's X is U over V, right? So.
Yes.
If we'd have U negative, then X must also be negative.
Yes. But then V could be negative. You know what I'm saying? U and V, I think, could both be negative. Because then X would be positive, and then Y would be positive. Right?
Oh, okay, I see.
I think you're correct that... I think they both have to be positive, or they both have to be negative. Is what I want to say. Okay. I'm just going to assume we're going from 1 to 9. Sue me if I'm wrong. Or, sorry, 1 to 3. Just because it looks like the nicer thing. So I'm going to say U is going to go from 1 to 3. And then I'm going to say that V goes from 1 to 4. 1 to 2, sorry. Can I show the question again? Yes. So, if you ever want to see the question that's being worked on in its, like, naked beauty, go to the website, actualofficehours.com, click on the live queue, and then the question at the top of the queue here, if you click on their username, see it says click username to view, that will show you the original problem. Zeke says, I hope we don't have to split the cases. I'm going to assume we don't. You know what? At this point in my life, if I was taking this on a test, just practically, I would take the partial credit. If someone else in the chat wants to explain to me like why I have to go one way or the other, sure. I'm just going to assume I have to do it this way. How can I delete the screenshots? You can't. So be careful what you upload. I can delete them manually, but okay. So 2U over V times that gets you 2U. And then plus 2U squared over V. du dv. This is Calc 3. Okay, so doing this, double integral means we look at this thing first and do this integral. So the integral of 2U is 2U squared over 2. So that's just going to be U squared. And the integral of this is U to the third over 3. So that's plus 2U to the third over 3V. And then that's evaluated from 1 to 3 for U. Okay, so we're going to plug in 3 for the U. And so what I get there is 9 plus, that's 27 over 3, which is 9, so 18 over V. So that's the first one, minus plugging 1 in for U. And so now that's 1 plus 2 over 3V. What's up, Don? I can help you with a question. Submit a screenshot. Very easy. I love Don. Don's great. Shout out to Don, by the way. Let me shout him out. Don's another awesome math streamer. He's actually in grad school for, I think, applied mathematics. Is it Don Factorial now? I think it's Don Factorial. Yeah, Don Factorial. As someone who's bad at math, nobody's bad at math. You're just not good yet. You're not bad at math. I want to banish the word I'm bad at math. I don't think anybody's bad at math. I think people just haven't gotten good at it yet. Thank you.
My man.
Okay. So now we do this integral dv. So this is going to be 9v. This is plus 18 ln of v. And then we have minus v. And then minus 2/3 ln of v. And then that's evaluated from 1 to 2. So the beautiful thing is that all the ln of 1s will go away. So I don't need to worry about those later. Okay, so 9v minus v is already 8v. So let's make our life a little bit nicer. So this becomes 16 plus 18 ln of 2 minus 2/3 ln of 2. Okay, and then minus 8. And then the ln terms go away. So the final answer, I think, should be 8. And then 18 minus 2/3 is ugly. What is that? 17 and a third? 52 thirds? 52 thirds? No.
Yeah, 52 thirds.
52 thirds. Yeah, okay, cool. 52 thirds ln of 2. Nice. Okay, cool. I think that's it. Let me know if it's right. Looks right to me.
That's dope.
I actually think by symmetry, if you went over the negative cases, it would be the same thing.
You think of the negative cases, you get the same numbers?
Yeah, because it's symmetric, right? So it's because x and y are just going to be hyperbolas in the first and third quadrants, right? And they're going to be symmetric.
Oh, I see. Yeah. And because you have a bunch of u squareds and stuff. Yeah. Oh, okay.
I think, maybe.
I think it would be too. Damn, man, how long queue you got there? Yeah. Don't worry, we'll get through them. I got 2 hours. All right, that was Nahar. Great job, Nahar. Great question. Let us know if it's right. I assume like you have solutions for these. I could just throw it into ChatGPT, but I don't know, I'm becoming less and less trusting of AI these days because it's getting more shit wrong. BK, this final's gonna destroy me. I have a 93 right now in Calc 3, but there's so many integral formulas to memorize. Yeah. Here, let me give you like a little cheat sheet. You want a little cheat sheet real quick of like Calc 3 stuff? Because I was actually just tutoring a student in Calc 3, and I really liked what their teacher gave them as a cheat sheet. Was that your question, BK? Was that yours? Yeah. Here, let me get you the cheat sheet real quick. Or is it Calc 3? Oh, you have yours on. Okay, cool. All right. Well, I'm gonna help you guys out. Let me find. I was working with this student today on Calc 3. Yes, here we go. So I think these are cool. 3D center of masses. Yeah, I can do it. It's a bunch of integrals. But these are pretty good. So these have kind of like the divergence theorem, the line integral, flux theorem, and then it's funny, they do the flux integral, they do the Jacobian stuff for you for converting it. And then, yeah, some vector field stuff. Yeah. Yeah, well, yes, most professors make you use the equation sheet provided by your professor, but I know. But if, you know what I'll also do? So in the Discord on this same question that we just did, I'll post this. And this also comes with, actually, some more practice questions that the professor gave the student. And they have the solutions for them, too. So this is like a practice final that some student I was working with had to do. And I thought it was pretty good. I thought it was a great overview. Not too tricky, but not too easy either. So I'll post that in for you guys. Let me download it real quick. There you go, solutions. Yes, Discord link. It's in my bio. It's also on that website, actualofficehours.com. If you click join the Discord, it should load. It's having some issues with international people. For whatever reason, I don't know. It's just being fucking weird. But if you just Google Actual Education Discord, one of those links will work as well. So wait, whose was this? This was yours. So I'm gonna post this in Nahar's. So in under homework help in Nahar's question, because that's the one that was using vector calculus. I'm gonna post this PDF here that has like a review test that I went over with him. You went to the wrong Actual Education and got a virus? Who's this imposter, dude? I want to know who's the imposter. Who's the imposter education? We're all the first ones, dude. If you type it, if you go to Google, dude, go to Google and type in like Actual Education Discord. We're like the top fucking 5 links. Like all of these are us. I think we're at the top of probably Discord servers for education too. Where are we? Man, we should be the top, dude. Who else is education, dude? What's this like Mika Paradise, dude? What? This is not education. This is fucking weeboo shit. What is this? The fuck? I need to talk to all these companies about like. Also, I don't know why we don't show up here. It's so dumb. Okay, whatever. But under Google, it's there. No, I'm doing everything. I want to do a chem problem. Did anybody submit a chem problem? Because I have so many awesome chem friends who also want to do chemistry, but no one ever like submits chem questions. I am a community server. We are a community server. Yeah, we're 100% a community server. I don't know why it doesn't show up though. Yes. So SB, we literally just went over this. So yes, so there are formulas, right, for all the surface area integrals. But if you want to figure out how to do that, how to transform dx dy for any other parameterization SB, this is what you do. It's called the Jacobian. So look up Jacobian surface integral, I guess. Yeah, this will show you how it works, I guess. Yeah, just type this in. So yeah, the area element is equal to this. It's the cross product of the derivatives with respect to your new parameterization. And then this is like, yeah, dA. This is probably a great video. Whoever's video this is. Yeah. Don't study an hour before the exam. Okay, I'm gonna move to the next question. Let's see what we got. Okay, yeah, if he tells you the formulas, then yeah, you're great. Here's a beautiful example. Here's another one. Compute the flux. Okay. I'm not just doing Calc 3, but the algorithm is sending me a bunch of Calc 3 right now. So please send me something other than Calc 3. Am I a teacher? I taught at UCLA for 2 quarters this year. But I signed on with a startup to do stuff because they pay more than being a teacher. They don't pay very much at UCLA. Yes, I agree, Psycode. Yeah, practice the Jacobian. It's much better. Flux. So, again, and out of the box. So, here you go. This is the flux integral. It's f dot dA. Is it just a box? Do we have to do all the sides? I really don't want to. Is there an easier way to do this? Yes, there's this. The divergence theorem. No, I need something with the curl. This Stokes theorem, maybe? Is it curl f dv? You know what I'm saying? No. Fuck, what is it? I don't want to do all 6 sides. Because, yeah, one way to do this would be do the integral of f dot dA. But then you need to do it for all 6 sides, which is annoying. I feel like there's a theorem here that allows you to do it without doing all 6 sides, all 6 surface integrals. It's not like Gauss's theorem. All right, one sec. Let me see. I'm gonna peek. I'm gonna peek to see what chat does. I just want to see what the theorem is, and then I'll do it. I'm not gonna actually just like do exactly what chat does. I just want to know what the. I think it's some curl integral I'm allowed to do. Yeah, divergence theorem. Yeah. Okay. Okay. Got it. All right. That's all I need to know. It is Stokes theorem. No. Apparently it's the divergence theorem. I think it's this one. Yeah, that's why I said I had to like just kind of like remember how to do it. Got it. Okay. So the integral of f dot dA, which would have to be across all 6 surfaces, because this is a cube, right? Is the same thing as doing the volume integral of the divergence of f over the region. So we're gonna calculate div f. So div f is this. What is flux? Flux is like It's like the amount of arrows going through a shape. I like to think of it as like the wind is kind of like the flux, you know? Like if you want a boat to move really quickly, the sail needs a lot of flux. You need a lot of wind, which is like a vector passing through a surface area. That's kind of like flux. Do the hard integral. The hard integral would be 6 of them, though. That's another good one. Flow of water through a fishing net. I like that too. Yeah. Okay. So this is div f. It's under Nahar's post in homework help SB, and the solutions are there too. What's your name in my Discord? I'll tag you. It's not SB 1214, I guess. Okay, div f, so that's the same thing as, this is going to be dfx dx. Yeah, who's got a chemistry problem? Someone give me a chemistry problem. If you submit a chemistry problem, let me know. We're offering you get a fast pass if you submit me a chemistry problem. Okay. This is dived off of f because you're doing the, like, I call it like the directional derivative. I know that's technically not the right term, but you're doing like the component derivative for each corresponding component of f, and then because it's a dot product, you add them all up. I met this girl and there's no chemistry between us. I need help.
You done messed up, Aaron!
Okay. Summer, give me a problem. I'll do it. All right, so dfx. dfx means look at the x component and take the derivative with respect to x. That's going to be 2x. dfy means look at the y component of f, take derivative with respect to y. That's going to be 4xz. And then dfz, dz means look at the z component, take derivative with respect to z. That's just going to be e to the x. Yeah. Oh, Sabor? Cool. I'll tag you. Sarbor? Got you. I'll tag you. Okay, cool. This is div f. All right. And now we just do a volume integral. So a volume integral means that we have 3 bounds, and this is going to be dx, dy, dz. And then what's beautiful about this is that the shape is just a fucking box. So I can leave this in Cartesian. I don't got to go to polar. I don't got to go to spherical, cylindrical, whatever. And my bounds are simple too. X goes from 0 to 3. Y goes from 0 to 2. And Z goes from 0 to 1. So the first thing we do is the derivative with respect to x of all 3 of these things. So that's going to be 2x squared over 2. So that's just going to be x squared plus 2x squared z. And the integral of e to the x is just e to the x. And then that's from 0 to 3. So that's going to be 9 plus 18z plus e to the 3 minus zeros. So 0. That goes away. And then this is e to the 0 is just 1. So minus 1. Nice. Can somebody ban bro? Oh, it's okay. I can translate things, Ghost. It's okay. We have ChatGPT. Phil's fine. He can say whatever he wants. It's okay. I don't ban people. I mean, unless you're being like toxic, then I do have to ban you, or you're doing something that's gonna get me banned.
Disqualified.
No. Don't do that, please. Okay, 0 to 2, 0 to 1, and then this is dy dz, dy dz, as they say across the pond. Integral of this with respect to y. Well, none of this has y's on it. So that means you're just going to pop a y on everything, and then you're going to do insert 2 for y and then 0 for y. So everything here just gets multiplied by 2. You could say it's this whole thing, right? This is 8 plus 18z plus e to the 3rd times y from 0 to 2. And so that's just going to multiply, put a 2 on it. He's Canadian, dude. He's halfway across the pond. Okay, so then 0 to 1 dz. Cool. So this becomes 16z plus 18z squared plus 2e to the 3 times z. And then that's evaluated from 0 to 1. So the answer should be 16 plus 18 plus 2e to the 3. And then the zeros are going to go away. So yeah, that's... Did you see Justin Trudeau is dating Katy Perry? Like what? The Prime Minister? Didn't he get in a bunch of trouble? Like his wife divorced him after he found out like he was like diddling kids or some shit. No. God damn it. What's up with the politicians these days? Yes, I'm live on Twitch. I'm live on YouTube. If you want to figure out all the places we're live, go to the website, actualofficehours.com. And then you can click here, watch live on Twitch. It's actually better on Twitch because it's like horizontal. YouTube's also great for discovery because it's in vertical, but he's French. He's allowed to have a mistress. He's Canadian. He's not French. He's Quebecois. Okay. 34 plus 2e to the 3. Let's see. What did I think we had ChatGPT do this one actually. 34 plus 2e to the 3. Nice. Nice. Look at that. We got the same fucking answer. I love that, dude. Nice. Cool. Good question. All right. I'll save that. That was Nazario. Jacob says, I'm switching my major from Bachelor of Arts to Bachelor of Science in Agriculture. How hard will it be? You're going to have to take more calculus, I believe. I think the difference between a BA and a BS is more math. And then I think some harder sciences. Almost like math is an exact science. What does it mean to be an exact science, dude? Like, some of the upper levels of math is not exact. Like, there's some weird shit going up there, dude. Riemann sums. Riemann sums are great. I actually explained Riemann sums, I think, beautifully in my last stream. Iman, if you want to go watch, again, also all of our every single thing I do here on stream is recorded, which I mean could be a bad thing. But if you go to our YouTube here, I think it was the stream yesterday. I think it was this one. If you click on this one, like a factor of 4. Let me turn the audio off because it was being loud. Where did I do it? Yes, here. I did it here. If you look around the 30-minute mark, yeah. I do Riemann sums. I explain. I take like a half hour to explain how Riemann sums work. I did this yesterday. It was very cool. So I highly recommend. Go check this out. It's yesterday's stream. Or not yesterday's, the last stream, which was on, what was that? Wednesday. Not the no chemistry chat. Okay, is there a chemistry question? Someone, if there's a chemistry question in the queue, someone tell me that there's one there, and I will do it. I'm in a Calc 3 hole right now, because the algorithm knows I'm doing Calc 3. Okay, so this was Nazario's. Let's move this over. Can you explain van der Waal forces? Isn't that, what are van der Waals? That's a chemistry thing. Is that London dispersion? I always forget, like, which one's which. Cater's like, I can explain it. Yes, it's the force every molecule has, which, oh, Jesus Christ, yeah. Dude, this language, dude, what? Yeah, I don't speak Arabic, unfortunately. I wonder if chat could transcribe Arabic, though. Pretty cool, though. What do you... I'm trying to, like, understand what he's doing here, though. This looks like complex plane stuff. Troy? I will say, dude, Arabic is, like, some of the prettiest. Like, look how fucking pretty this font is. This is beautiful. Looks like artwork to me. This is really cool. What the hell is that? Yeah. I think this is complex analysis. Here, let me throw this. I'm gonna throw this in the chat.
There's no way this is complex analysis.
Oh, you don't think it is?
Sorry. No.
What do you think it is?
No way. I did this last year.
I saw like argument of z. What does arg mean? Does that mean like the angle?
It's the angle alpha, such that the tangent of alpha is y over x, where the complex number z is x plus iy. That's the argument.
Apparently,
it's actually the angle that the complex well, how do I say this? It's the angle that the absolute value of the complex number makes with the OX axis.
Oh, okay, I see here. Yeah, here. So this is what the translation said. A complex number z such that magnitude is 2 and argument of z is pi over 3. I get it. So the angle is pi over 3.
Yeah, it's the angle it makes with the horizontal direction.
But then what is k? Like what? I don't know. That's probably other parts of the question. Wait, whose was this? This was the Ghost. Ghost, is there a specific question number you wanted me to do? Because there's like 20 questions here. If you Ghost, tell me which one you want me to do. You're losing me, chat. More trig. Chem. There. Okay, someone did submit a chem question though. Yes, here we go. All right, I will do this chem question. Ghost, you let me know the last one. Okay, I'll do the last one. Ghost, let me do this chem question real quick. We love chem. Chemistry. More chemistry. Okay, there we go. All right. This is called. Oh man, what is this called? What's the name for this? Man. It's a cool dude's name. Hess's law. That's it. Now wait, would I spell Hess like this? Is this Hess's law? Narosky, didn't you say this is like 2 S's? Like the beta thing?
Yeah. Yep.
Yeah, maybe would it be this? Hess's law?
It's like a beta. It's like a beta with a longer, like, yeah, like that. Well, no.
Okay. Okay, determine delta H per mole for this reaction. So this is the cool thing. We're trying to get to here using this as like building blocks. Sick. Okay. So, I know I need 2 A's on the left-hand side, right? So I'm going to look here and be like, all right, which equation has A in it? Well, just this one, right? So I'm going to say 2A goes to C plus D. And that's going to equal 2. That's going to have a delta H that equals 2 times 151, right? The problem's off screen? So wait, okay, I think it's correct on TikTok, but I've heard that before. One sec, let me just see on TikTok what this looks like, because according to my streaming platform thing, it looks fine, but I understand it could be wrong. I'm gonna check my phone real quick. That's a good question, actually. This should be right. Oh, it's fine now? Okay, cool, thanks. All right, just making sure. There might be a little bit of a delay. Okay, so this will get me 2A. I need to get 2 E's, so I think I need 2 of these equations. So I'm going to say 2D plus E goes to F, and that's going to equal delta H is equal to 2 times negative 52. And then I need a C. We already have a C on the right from here. I need a G. Okay, so I look at this, right? This has 1/2 G going to the right. So I need G. Well, G's on the left and it's pushing right. I need G to be on the right, pushing left. Or whatever. I'm going to flip this. And I'm going to multiply it by 2. So when that happens, I want 2 F's going to 1/2 G. And because I flipped the order of this is now going to be delta H is equal to negative 2 times 84. So the negative is what allows me to flip the order of the reaction, the direction. Okay? So now let's add this all up and let's see what we get. Okay, so I have 2A plus 2D plus 2F is going to 2C plus 2D plus 2F plus G, right? Because 2 times 1/2 gets me G. And then let's see if we can cancel some things. It's kind of like algebra. It's like, this is actually kind of math. So 2D cancels with 2D. 2F cancels with 2F. And then we're left with... Oh, I forgot the E. I forgot there was a 2E here as well. My bad. Uh-oh. Let me fix that. Thank you, Psycode. I did. Okay. Yes, and now we're left with 2a plus 2e goes to 2c plus g. And look at that. That's the same reaction we were looking for. All right, so all that's left is to like add all these things together. So that's 2 times 151, which is going to be 302. Plus 2 times negative 52, so that's negative 104. And then minus 168. So what is that? Minus 272. Did I do math right? I'm pretty sure I did math right. Yeah. Okay. So this is 302 minus 272. So the answer should just be 30. Oh, but here's the interesting thing. Oh, they tried to be tricky. They said per mole of A. This is for 2 moles of A. Aha, Matthew. Good call. Yeah, okay. So this is delta H is equal to 30 joules, or 30 kilojoules. But per 1 mole of A, that's going to be equal to 15 kilojoules. Nice. I agree. I think that's great. Cool. Great question there.
That's dope.
So cheeky. That's such a... Yeah, so cheeky there. Look at that. Calculate per mole. Why'd they fucking do that to us? That's fucking rude. Nice. Good question, Summer. Did that help you out, Summer? Summer? Did it help you out? I know it made our chemistry friends really happy. Yes, nice. Okay, if you stick around, I'll do your next one in a bit. But let me go work with the ghost. But I appreciate you submitting a chemistry thing. It will probably help out the algorithm to give us more chemistry things, which we love. We love more chemistry things. So I'm gonna post a solution to this too in our Discord. So if you want to go check it out, it'll be there. Chem 1? Yeah, that's probably Chem 1. Oh, wait. I already had yours. So that one, post 9. I love Chem. I like Chem too. Chem is one of my other favorite subjects to teach, for sure. You know, I bet, like, we get a lot of Chem questions around, like, whenever the MCAT is being administered or something, right? Chem is great. Yeah. Someone want to give me an OChem question? Can we switch to physics too? Let me do the ghost question, because the ghost has been patient. And then maybe I'll look through the queue and see if there's a physics question to do. Otherwise, I'll keep going in order.
If you guys want to do physics, I can post my problems that I had on my competition for you to try.
I would love to see those at some point. Maybe not today's stream, because that would like kill me. But yes,
Dude,
I do want to see those.
Yeah,
Yes, they're kind of tricky.
Yeah.
Wait. So Ghost, you said the last one. I'm sorry. I gotta go back to my chat now with what Ghost said. Excuse me. Sorry. Yes, Ghost. Is it this one down? Is it this whole thing down here? Or I think it's this one. I think it's this right here. Got you. Okay, cool. Let me get the translation for this. Okay, cool. Is this the find the real numbers such that the roots are this? You translated my chat. Yeah, sorry. My chat just like goes crazy. Where is my chat? Could get it wrong. Does this look like it's right though?
This looks okay.
Yeah, this looks okay, right? I feel like this is fine. just try to do this one. Find the real numbers p and q given that one of the roots of the equations is 2e to the 5 pi I over 12. Ooh. Okay, Narowski, you want to help me with this one?
Doctor,
What's up?
Are you more familiar with the cosine and I sine representation of this, or is e to the power 5 pi over 12?
So, I know you can represent e to the ix in what's it called, like a cos, what was it called? What there's a name for it.
I don't know what it's called, but it's cosine of the argument plus I times sine of the argument.
There's two questions before this.
Exactly.
Wait, yeah, no, what's it? I know what it's called. There's a format for it. Ghost, do I need to know the other two questions to do this one? Oh, like 1 and 2, they're all related. Oh wait, one sec. Let's okay. Apparently they're all related. I forget that Arabic goes from like right to left. Okay. Euler's
Oh yeah,
yeah.
I see there's.
Okay, here, let's get the translation for this. Euler's formula? Yeah, but there's a name for it. It's called like there's a name for the form. Oh. Right, z1 over z2 in exponential form. Okay. Okay, but then I need z1 and z2. Right, okay, that's there.
Well, you can see Z1.
Oh, here's z1 and z2. Oh, I'm dumb. Okay, thank you. Got it. Ah, yes. Yes, y'all are correct. Y'all are super correct. Yeah. Okay, so it's e to the I theta, I think is, and then it's r e to the I theta, right? Is equal to, is it r cosine theta plus ir, oh, well, here we're gonna do r cosine theta plus I sine theta?
Yeah.
Okay, cool. Interesting, but I need a negative here? How am I gonna get a negative?
Cosine is a
Negative
even
cosine,
function, right?
yes. So that's the same thing as just cosine of pi, cosine of negative pi. Wait. Cosine.
If cosine is even, so if you can bring the negative
In, but then it
inside.
yes. Oh wait, what the fuck? One sec. I gotta refresh this. Negative theta. Yes, I agree. Okay. Sorry. Let me refresh.
Yeah, and then we can bring cosine of negative theta back into the first quadrant.
I don't know why my whiteboard went down. Dude, my whiteboard never goes down. That's why I pay money for this service. They almost never die. What? Excuse me? No. Uh-huh. There we go. Okay, we're back. One sec, sorry. Okay, here we go. Coming back. Okay, then let me move all these down. One sec. Let's move these down. Move these down. Okay. Right, okay. So I can write this as the same thing as 2 times cosine of negative pi over 4.
Yep.
No, that's wrong. I agree with Nico. I don't think... No. Yeah. I think you have to do cosine of 3 pi over 4. Yeah. Pi negative, pi minus. Yes. It's pi minus pi over 4.
Yeah, that's what I was gonna get at, but yeah.
Oh, okay, I got
that's
you.
exactly.
Got you. Okay.
Yeah, which is just 3 pi over 4.
Right, okay. So this is 3 pi over 4. And then plus I sine. So,
Well, a sine of 3 pi over 4 is just
it's the same thing as sine of pi over
4.
4. Yes, they're the same thing.
Good job.
Yes, this is also sine of 3 pi over 4. Right? Yes.
Yep.
Nice. Love that.
Nice.
Equals the sine of 3 pi over 4. Aha. Now we have the same angle. So this is just going to be equal to 2e to the 3 pi over 4i. Is that correct for this one? For Z2? Nice. We're making progress. And then, okay, Z1's already in that form. Okay, so in exponential form...
We just want the...
We just divide them, right?
Z1 over Z2.
Yeah.
Yep.
Let's do it. So that's going to be... What was Z1? Oh, negative 4. E to the pi over 6i divided by 2 e to the 3 pi over 4i. This is not the nicest common denominators, but it's okay. So negative 2... I can just do exponent rules, right, Narowski? Yeah?
Wait, why negative 2?
Why what? Sorry.
What?
Bro, you need to get the negative out. Why? Why did I get the negative out? Isn't Z1 have a negative on it?
1 second.
Crazy.
Oh, I see. So, wait, hold on. Negative 4, you can write any real number as exponential form. You know how we just did this for complex numbers? We just have to do this, but with the sinus, like 0, you know? Because the cosine is the real part.
Gotcha.
If you look at it, right? So this negative 4 is just e to the I, 4 e to the I pi.
Yes, yeah. Okay. I was gonna divide it, but I get it. I get what you guys are saying. This is e to the no, you're good, Alistair. You're not late.
Good job.
This is for e to the I pi I.
Yeah.
Yes. Cool. Love that. Yeah. E to the 2i pi is 1. Where's Zach, dude? Let me shout out Zach. Was Zach streaming this morning? Or it was yesterday, he was right. E to the 2i pi. Shout out Zach. Perfect, chat. Okay, cool. All right, so we have 4e to the pi I, and then it's e to the pi. Yo, what's up, Sam? Good to see you, dude. And then it's e to the pi over 6i, right? So then I can add these, right? So this is e to the 7 pi over 6.
Yeah.
Nice. Someone just keeps submitting chem. Good. We like chem. Okay, cool. All right, so now it's 4e to the 7 pi over 6. Now I think I can divide them, right?
Yeah, you can divide them now.
Okay, now it's equal to 2. And then this is going to be e to the this minus this. So 7 pi over 6 minus 3 pi over 4. Again, not the nicest. So whatever, this is 24, 28.
Why
and then
24?
Because I'm multiplying the top and bottom by... Oh, I could just do them by... Dude, all right, I don't...
Disqualified.
It multiplies by 2, dude. Yeah, okay, thank you.
Yeah, by 2.
I was making my life hard. And then this is 9 pi over 12. Okay, cool. So we get 3 pi over 12, which is pi over 4.
5 pi over 12.
No, 5 pi over 4. Sorry. I saw the 12 for some reason. 14 minus 9 is 5.
Yeah.
5 pi over 12. This is your 12th grade quarter exam? That's cool. What part of the world are you in? I'm curious. In algebraic form. Okay, in algebraic form, right? So this is 2 cosine of 5 pi over 12 plus 2i sine 5 pi over 12, right? Is equal to 2e to the 5 pi over 12.
I don't think this is algebraic form. This is trigonometric form.
Okay. Oh, sorry. Write it in algebraic form. Oh, okay.
Yeah, we want the algebraic representation, so...
What does it mean by algebraic representation?
Like, x and iy. X
Oh,
plus
okay.
iy.
Oh, sure. Okay, fine. So this is 2 cosine 5 pi over 12 x, or what? Do you want it in like vector form, like this, comma 2 sine 5 pi over 12. Is that algebraic form?
This is what happens when you know too much, right?
I know too much.
No, I don't think he knows vectors. In 12th grade, I don't think you do vectors. Like
He might do vectors in 12th grade. I did vectors in 12th grade. The way you write pi gives me the ick. What's wrong with my way I write pi? You don't like this, dude? It's beautiful. Just don't shame my pi. Okay.
The way I would do this is I would take Z1 and Z2 again and compute what they would be algebraically.
Oh, okay. Oh. I see what you're saying. I see.
So I would look for the algebraic representation of them, and I would do the Z1 divided by Z2 again.
Oh, that's annoying. Okay. Sure. Okay, so, ooh. I'm in 12th grade doing point set topology, so I'm not surprised people are doing vectors in 12th grade. Good for you, Jai. I have no fucking clue what point set topology is. Sounds scary.
Surprise, motherfucker.
Alright, one sec. Let me read. You need to put the trigonometric form Z1 and Z2, and then put the values. Okay, cool. Got you. Okay, so this is 4... Dude, but 7 pi over 6, is that a nice number? Oh, it is, it is. Yeah, that's one of the 30s. Okay. So 4 times, got it. 7 pi over 6. Do I still put the I, do you think?
Yeah, of course.
Right, okay. Plus I sine 7 pi over 6. And then here, I'm going to show...
I would actually transform this into... I would bring the negative out. Do you know what I mean?
Out of this?
Out of all of that, I would write, instead of 7 pi over 6, I would write it as pi over 6.
Oh, I see.
Yeah.
I'll show you. I know what you're talking about. I get it, because it's going to be in quadrant 3 and you want it in quadrant 1.
Yeah.
Yes, you could do that. Let me show how. Let me show for the white.
Oh no, you
don't. Yeah. Because I agree, because everything here is in quadrant 3. Well, no, this is in quadrant 2.
Yeah, that's why I wanted it in quadrant 1, because it's different quadrants. But
got you.
I don't know. Doesn't matter. I don't think.
No, it's elegant. Again, and I always appreciate the elegance. The elegance is nice. Let me show like why, because some people probably wonder like, do I need to use the unit circle to know this? And I'll be like, no. We're gonna do a little learning here. Okay, right? Okay, so pi over 6 corresponds, well, not approximately, equals 30 degrees, right? And then any of the pi over 4s is equal to 45 degrees. Okay? So, I'm gonna show you how you do this without having to do the unit circle. You just need to know 2 triangles. Someone earlier on my stream was asking, like, how do you do the unit circle without memorizing it? I'm showing you how to do it. So, 1, square root of 3 over 2, 1/2. These are the 2 triangles you need to know. Where this is 30 degrees. Sorry, no, this is 60 degrees. This is 30 degrees. And then the other one you need to know is the 45, 45, 90, which is 1. This is square root of 2 over 2. This is square root of 2 over 2. Once you know these, you are all powerful, and you can do anything on the unit circle. I'll show you why. So let's look at 7 pi over 6. Where is that on the graph? Okay, that is pi over 6 beyond 6 pi over 6, which is just pi. So I know that my angle is going to come over here, and this is going to be pi over 6. Okay, because that's what 7 pi over 6 is, because this is 6 pi over 6. Why did the teacher not teach you this and make you memorize the unit circle? Because he's lazy. Anyways, okay, so pi over 6 is the same thing as 30 degrees, okay? And then here's what you're going to do. You always connect this to this axis. Do not connect it here. Like, some kids will do this, and like, this is so wrong. No. Don't do that. Always connect it to the x-axis. Okay, so once you do that, once you connect this is a triangle. And it's one of these fucking triangles, right? And what we know is that opposite the 30 degrees is a 1/2. And then the hypotenuse is always 1. And then the adjacent, which is the one not opposite the 30 degrees, that's square root of 3 over 2. But then be careful. Be careful. Because we're over here, this is negative and this is negative. Because I'm below and I'm to the left. Okay. So this is really cool. Because now if I want to calculate, for instance, what the cosine of this 7 pi over 6 is, I just look at what the adjacent over hypotenuse is of this triangle. Because cosine adjacent over hypotenuse. So this is going to be this over this. So that's going to be negative square root of 3 over 2 over 1, which is great. And then the sine is just going to be negative 1/2. Because that's the opposite. And then you can kind of do the same thing here for 3 pi over 4. Right, so 3 pi over 4 is over here. Here, let's like move this down a little bit. Yeah, well, running out of space. Actually, I'll just make a new triangle. We'll make a new little axis for it. All right, so 3 pi over 4. This is 2 pi over 4. Sorry, this is 2 pi over 4. This is 3 pi over 4. So this is going to be 45 degrees. And then the 45-degree triangle is this one. And so that's square root of 2 over 2. Square root of 2 over 2, except this one is negative. And this one is positive because it's above. All right? So that means when figuring out cosine, which is adjacent, the adjacent on this triangle is the negative. So this is negative square root of 2 over 2. And then the opposite is positive. That's positive square root of 2 over 2. Great. The other way, yeah, Naroski had another way, was I could have transformed these angles back and then just put negatives in places. Yep. That's a way more elegant way to do it. But for the purpose of teaching you guys this, that's why I did this.
While you were explaining this, I actually found out that you don't need to do this.
Oh, we don't need to do this. Oh, what? What do you mean we don't need to do this?
Like, we don't need to do any of this.
We don't need to do any of this.
For E, like, we already have what this is equal to, right? We already have Z1 over Z2, right?
Yes.
So I think I was just making our lives more difficult.
Okay, well, I like my life being difficult. That's okay. Is it because... Wait, is it...
So what was Z1 over Z2?
That was... Well, I forgot where it was at this point. Oh, shit. Yeah. Where did we put it?
Did we delete it?
Did we delete it? That was bad. I think it was this, though. I think it was 2e to the 5 pi over 12i.
Yeah.
Yeah, it was this. I'm pretty sure that's what it was.
So, if what happens if we write this in trigonometric form?
We're gonna get this.
Can you go a bit? No. Can you go a bit down?
Yeah, let's put it down. Yeah, here. Let me put this down.
Yeah.
Sweden, you call those the triangles of engineering? Oh, that's great, Roman. Cool, man. Yes, I agree. Francesco. Yes, so this is 2, and then this was cosine of 5 pi over 12 plus I sine of 5 pi over 12, right?
Yeah.
All right. So were you guys just going to tell me that, like, this is equal to, like, whatever this is minus this or something? Is that the answer?
Well, no. Look at what it's asking. It's asking what cosine of 5 pi over 12 is.
Yes. So, like, what is this?
Yeah. And we can just do this, and it's going to be easier.
Okay. Am I going to divide both sides by 2?
Well, no. This is Z1 over Z2, right? This is equal to Z1 over Z2.
Ghost says I was doing it right the original way. Let's see. You tell me. Tell me, Nora.
Okay, let me tell you what I think Ghost is saying by that. It says write Z1 over Z2 in algebraic form, then deduce that. So I think we are gonna just be doing this backwards, right? If you want to do this quicker, you have to do it backwards.
We're gonna do it quicker. We can do it backwards. Oh, you mean like find cosine of 5 pi over 12 first?
Yeah, and then find out what that is in algebraic form without just computing everything brutally, you know?
Oh, without doing this stuff.
Yeah, without doing that. That's just... Why would you do that? I don't know.
I guess it's just the method they want you to do it. All right, what's your way of doing it? Are you saying I'm going to solve for this?
Yeah, just find out what that is. And
okay, so what?
If we do, yeah.
Like, right? This, and then minus...
Well, no, you don't need to divide by 2. No.
Well, there's a 2. Here's a 2 here. No?
Well, those are equivalent statements. You don't need to divide by 2. You don't get nothing. You don't get anything by that.
Okay. What do you advise?
I advise that we go to a new line, right? We go a bit down. We ignore what we have now, and we want to find out what cosine of 5 pi over 12 is. No, don't cut that out.
Okay,
No, we just want to find out. We just want to find out what cosine of 5 pi over 12 is.
Okay.
This is what we want to find out, right? And cosine of 5 pi over 12 is the same thing as cosine of pi over 4 plus pi over 6.
Oh, okay. Okay, I agree with that.
No,
Yes.
now just use the identity for cosine of a plus b.
Oh. Okay. Yeah. So is this cosine pi over 4 sine of pi over 6?
No, it's cosine of pi over 4 cosine of pi over 6.
Oh, they're both cosine. Okay. I forget which one it is. And then that's minus.
Minus sine.
Minus sine, right? Sine pi over 4. Sine pi over 6. Okay, and then this we know is square root of 2 over 2. This is square root of 3 over 2.
Yep.
Minus square root of 2 over 2. 1/2. So you get square root of 6 over 4 minus square root of 2 over 4. Square root of 6 minus square root of 2 all over 4?
Yep.
Okay.
And the sine 5 pi over 12 is just the same thing. Right, you just do the same thing.
Okay.
Because you need that also.
Okay. So then the sine of 5 pi over 12. This is a unique way to do it.
Yeah. Do we want to write this out? Because if you know the identities, I know the identity. The same thing, but it's the same thing, but with a plus instead of a minus.
Don't you switch these? Don't you switch these as well? Yeah.
You just it's gonna be 6 square root of 6 plus square root of 2.
Okay, square root of 6 plus square root of 2 over. Let's just trust that. Okay.
Yeah. Yeah. So now just go back and replace what we found.
Oh, okay. So then it was, what was it? 2. Yes. So 2
times the cosine.
Square root of 6 minus square root of 2 over 4 plus I square root of 6 plus square root of 2 all over 4. You can pull the 4 out, right? So it's just 1/2.
Yeah, you can pull the 4 out.
1/2 square root of 6 minus square root of 2 plus I square root of 6 plus square root of 2. Okay, cool. Technically, that's correct.
This is Z1 over Z2 in algebraic form.
That is in algebraic form. We could have also done it this way. I guess this would be kind of a headache, though, because then I'd have to multiply by the conjugate. Yeah, I understand. This way would suck. So, yes, Ghost. I totally understand that this is probably the way they wanted you to do it, but I am also a big fan of like thinking outside the box, because I think it's a beautiful thing about math is you don't have to solve everything one way. Would your teacher get mad at you for doing this? Maybe. But also, I think it's cinema. Yeah, it's pretty beautiful, right? This is pretty fucking cool. Yeah. So, Norosky, sorry. Oh, dude, I almost called you by my my sleepy name, dude. When I'm like sleep deprived. When I start calling Norosky Zarovsky, that's when I'm fucking tired. Yes, this is elegant to realize that 5 pi over 12 is the summation of 2 angles I know how to take sines and cosines of very easily. And then once you have that, you write out what the identity is for summation of angles. You get something, you do it for sine as well, and then you just reconstruct. It's beautiful. It is cinema, dude. That's very cool. I studied physics, plasma physics. Norosky is in high school. Yeah, Norosky's just like a Romanian genius. He's the other guy in the chat here that's talking. Yeah, it's like, what did you study? But okay, cool. All right, so we got that. Okay, great. We're happy with that. This would be the same process, but multiplied by the complex conjugate, and like, I don't know, it's a bunch of algebraic mess. All right. Let's wrap this question. Is this easy to do, Zarowski, or is this going to take me a lot of time?
If you want, I could do this. Do you know that if do you know complex conjugates?
Wait, one sec. Let's say Ghost. That's my whole problem because I couldn't get the concomitant. What's the concomitant to the exponential number of the denominator? Okay, maybe.
I think that's just a poor translation.
Okay, let me just do this for him real quick because I think this is probably his question. Let's just do this. We'll do it. We'll do it. What's up, Rora? All right, here. Let's just do this for you, because yeah, this is beautiful. But let's just see algebraically. Do I do linear algebra? Yeah, I do tons of linear algebra. Oh wait, no. Can I have it back? There you go. Let's just make sure they're happy. If you multiply 4 through everything, that goes away. So you just have 2. Right? So I got -2 square root of 3 cosine of 7 pi over 6. Oh wait, no, we already did. Sorry, we already did the cosine 7 pi over 6. Sorry, that's already done. Okay, yeah. This multiplies by this, gets you -2 square root of 3 plus or so minus 2i, right?
Yeah.
And then this gets me negative square root of 2 plus square root of 2i. Yeah?
Yeah.
All right. Now, in order to get rid of the I on the bottom, I'm going to multiply by the complex conjugate. So I'm going to multiply by -2 minus... Actually, let's just pull the -2 out. Like, let's just make our lives easier, right? Okay, one sec. Let me just... I want my life to be easy. I'm going to pull out a -2 here, and this is just going to be square root of 3 plus I. Yeah? And then I'm going to pull out a square root of 2 here. Or I'm going to pull out a negative square root of 2. And that's going to give me 1 minus I.
Oh, that's clever.
Right? This looks nicer, right? Because
Yeah,
then I multiply by 1 plus I. I did something clever? Rosky thinks I'm clever? Dude, wow, that's the highest praise I can get right now, dude. Okay. 1 minus I times 1 plus I. This is the difference of squareds. So this is 1 squared minus I squared. But okay, so this is 1 squared minus I squared. But I squared is -1. So that's 1 minus -1. So that's equal to 2. So that gets me -2 square root of 2 on the bottom. And then this is kind of a mess. I don't like this. This is kind of ugly. But anyways, we have a -2 times... So first of all, this is going to cancel. I won't need that. And then foiling this, you get square root of 3 plus square root of 3i plus I, and then -1 because it's plus I squared. Okay. So what is that? Square root of 3 over square root of 2 plus square root of 3. Well, I don't really like any of this. This is just fucking ugly. Square root of 3 minus 1. What was the actual answer? What were we looking for eventually? Oh, this. How do you think we're going to get that square root of 6? Oh, I know how we're going to get it. Okay. Now, I'm going to multiply both things by the square root of 2 over 2. I'm going to multiply top and bottom by this. This will get me square root of 6 plus square root of 6i plus square root of 2i minus the square root of 2 all over 2, which is my 1/2. And then we have square root of 6 minus square root of 2, and then plus I square root of 6 plus square root of 2. Bingo, same answer. Look at that, it's so pretty. Nice. Okay.
Bing, 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 bang.
What's up, clickbait?
That's dope.
Okay, I have 11 questions in the queue, so I'm gonna actually maybe save part 3. Narosky, if you want to do this, like, separately, maybe?
Oh, yeah, it's very short. It's not like a long solution, so I can do it if you want.
Okay, yeah. Here, Narosky will do this, and he'll write it up, and he'll put it in the Discord. I just want to make sure I get through everyone else's questions. But this is so far. You're very welcome, Joe. Okay, cool. Great. All right, let me keep moving forward. I'm gonna post this one. I learned a lot. That was cool. I like learning. Learning is dope.
That's dope.
Okay, this was the ghost. The ghost. And then here I'll tag Narosky in it too. All right, let's see. What do we got next? Josh. Ooh, I like this. This is physics, Josh. Yeah, dude, we got physics.
That's dope.
Okay, I'm gonna do a couple of these. I don't think I can do the whole thing because I don't know. That's a big document. You tell me, Josh. Is there a specific one that doesn't make sense? And then I'll do some chem cross. Yes, I will do chem. I promise. We still have an hour. The graph below shows a function. Cool. This is position as a function of time. So velocity is equal to... technically it's a derivative, but I think since you're in physics 1, I don't know if you're doing calculus. So I'm just going to say like delta x over delta t. You're going to say it's like the slope of position versus time. Okay. So whenever the object's velocity is 0 is when the slope is 0. And this is like the instantaneous slope. So that happens here and here. It's technically like undefined kind of. Clickbait says, I saw a really cool one in the channel the other day. Did you end up doing the one with the object sliding down a circle and then falling off at a certain point? I don't think we did. That sounds fun though. Okay, so I think this has velocity equal to 0 at point D and point G. Is the speed of the object the greatest? Ooh, so that's... So this is a trick question. Because speed is different from velocity. Speed is the absolute value. So if I were to say the velocity is the most, I would say it's at C. Because that looks like it has the most like positive slope. Speed doesn't care about whether it's positive or negative. It just cares about magnitude. Noroski solution, you can see it in the Discord. So if you go to here, join our Discord, and then it'll be in the homework help channel under the ghost. That's his post. So, wow, that kind of rhymes actually. Yeah. So if you go to, where is it? Homework help. His post here, the ghost. That's where Noroski will post. Yes, the speed is greatest at E.
Good job.
Yep, I agree. Speed is greatest at D. E. The velocity is greatest at C. Because it's the most positive. At what point is the object the greatest distance from the starting point? Okay. So the furthest away would be here, right? Because that's the furthest position. That's 5. Yeah, okay. So that's going to be position D. Where the acceleration is negative. So acceleration is negative means you need to be concave down. Because that's the second derivative of position. And concave down is like sad face. So anything that looks like a sad face. So I would say here. This looks like a sad face. So I would say C, D, and E. Identify one point. What's up?
Interject.
Yeah.
Concave down in my country is defined as, well, without proper definition, is defined as something that doesn't hold water. So if it doesn't look like
something doesn't hold water.
Then, yeah,
I like
if it cannot
that.
hold water, it's concave down. If it is
I like
concave
that.
up, it holds water.
Can hold water. There must be some fun cultural thing there. Like, yes, cool. This is positive acceleration. Yes, think about holding water. You can hold water in a concave up thing. Can't hold it in concave down. I think it's like the sad face. I'm like, look how sad this person is.
Bruh.
Is it possible to censor my name on the paper I sent you? It's written in blue at the top left, if you don't mind. Not easily. Here, I'll have once Noroski posts it, I can take the photo down, I guess, or something. Yeah, it's, you know, there's not really like Discord editing, but I'll take the photo down once he posts.
Okay,
Also, I don't think anybody can read your name. It's in Arabic, dude. What? Like what? none of us could even read your homework to begin with. Yeah, here I can I delete this message? I wonder if I can actually. Oh, I can. Okay, cool. Yeah, all right, it's fine because the question's in the other screenshot. Yeah, it's there. Got you, Ghost. Okay. Yeah, so negative acceleration, I would say D. That's the easiest one. What if it's accelerating downwards at 2g? Well, that would be very negative then. Determine the speed of the object at C. That's kind of up for interpretation. You have to like kind of like calculate like what this slope would be, which I don't know. That's like jumping. It's jumping a meter in like half a second, so that's like 2 meters per second. Average velocity between B and H. That's cool. So average velocity. Oh, it's cool. Yeah, you could draw a tangent at C. Which I kind of approximated it being here. Your teacher just wants you to just show what you're trying. So average velocity is change in position over change in time. So between B and H, that's going to be 5 seconds. So 5 on the bottom. And then what's the difference in the position? It's going from 2 to 0. So it's final minus initial, so 0 minus 2. So you can say negative 2/5 meters per second. Average speed of the object between points B and H. Ooh, that's interesting. Speed. Yeah, average speed is not, it's not delta x, it's changing the it's, That one's trickier, actually. Let me think about that. Take the modulus of 2/5. Is it really just 2/5? Because velocity is displacement over time. Average speed is distance over time. Which, yeah, I guess distance is the modulus of displacement. But is that true, though? I'm curious. Maybe it is. I'm just curious. Because if we think about the distance, right? It goes from 2 to 5. So it travels 3. Then it travels another 5 down. So it's actually... No. The average is actually 8 over 5. Oh, actually, even weirder. Sorry. 3 up, 5 down. And then it travels like another 1 down. And then it travels another 1 up. So it's 10 over 5. It's 2. Okay, Ghost, all good.
I posted Ghost's thing.
So nice. Thank you. Yeah. Yeah, I did. Yeah, nice. So, yeah, Ghost, Narosky posted this one. Don't worry. So here's the other thing. Yeah, you're welcome. All questions will get posted into the Discord eventually. So even if we don't get to your question or you need to go to sleep or something, every question on that queue gets put into our Discord and will either get solved by, again, one of my awesome actual educator friends who may donate their free time to just do it, or it may get done on another stream, or in the worst case, after 2 days, we have ChatGPT go eat it and it munches it. And sometimes it gets it right. Sometimes it doesn't. But you're welcome. Narosky, Homer's asking, how did you learn all that math?
I don't know. I just studied.
He says I just studied.
I usually skip school to study, so...
He skips school... Because do you find school, like, kind of useless? Like, it's kind of, like, beneath you-ish?
I find school boring.
Yes.
So it's so much stuff that I don't need.
Yes. Yeah, I agree. Yeah.
That is not 5 meters a second, I think.
Is it not 5 meters per second? Isn't it 10 over... Oh, not over to 2. Why the fuck did I write 2?
Surprise, motherfucker.
Oh my god, dude. It's 10 over 5, right? It's over 5?
I look away for 1 second.
Yeah, sorry. Yeah, dude, wait. Why did I solve this twice, actually? Sorry, what am I doing? I got distracted. Okay. Answer is 2 meters per second. Again, because you have to take into account... the distance this thing travels, not the displacement. Okay? That's the key thing here between velocity and speed. Yeah, so it's not the absolute value. Do you see how, like, 2 is way different than 2/5? Because you think about it, like, watch this. Here's an example. For an example. Let's say, I start here. Right? And let's say I go 2 meters per second for, I don't know, like 5 seconds or like 10 seconds. Let's say I walk for 10 seconds, right? So let's say I get out here to 20 meters. Okay. And then I come back, let's say at 4 meters per second, and I do it in 5 seconds. So I come back another 20 meters, right? Now my displacement is equal to 0. So my average velocity is 0, right? Because I didn't really move anywhere. But my average speed is definitely not 0, right? It's somewhere between 2 and 4. So that's why. Didn't realize it had negative displacement. Yeah, cool. All right, great. Cool question there. Thanks, Josh. Yeah, that's a tricky one. That last question was kind of tricky. All right. Did I save it? Sorry, where did I save it? Josh. All right, let's see. Someone wanted me to do a chemistry question. Let's go see what's in the queue. Let me go see. So we got David. David, you got chem? Ooh, you got circuits. Also, I don't know if I can help with developing op amps. Yeah. Cool question. I don't know if I can do it. Because I don't... Well, I could, like, look it up, but okay. And then Ghost has a bunch of other stuff. Okay, but Ghost had said he had to go to bed. Okay, that's fine. This is related rates. Oh, I love this. I will do this one next, but let me do a chemistry one, real quick. Summer has submitted a lot. Okay, but let me see if there's another person that... Okay, Dumo, I see you. Okay, cool. We'll do yours, and then... Oh, I remember I screwed this one up. This is actually kind of this is a tricky one. Actually, no, this one's easy. Sorry, no, this one's not bad. Okay, all right. This is a lot of steps, so I don't know if I can do all that. Summer, do you have something that's like chill? Must draw diagram. Let's do this one. I think this one's cool. The last one? Yeah, I'll do the last one, Summer. And then I'll go back and do more stuff. Tis a heat curve. Yes. Okay. So what do they want? Do they want, what is it? It's temperature, I think, versus, like, delta E. Is that kind of what we say? And so we're going to start here at 87.7. Whatever, like, put, like, whatever, some units. And this is going to go up. You do, but it's not too hard. We're not going to get crazy with the engineering stuff. I need to look up... Sorry, yeah, you're right. I do need to look up the specific heat of these things, but I think they're pretty well known. All right, this is going to go all the way up to 100 degrees. Okay. And then we're going to have it go through, like, heat of vaporization. So this is HVAP. And then it needs to, like, keep going up as steam. Up to 121. Okay. Okay. So, the first stage here is getting water up to boiling point. That energy... Well, we can always figure it this way, right? So, Q is equal to MC delta T. MCAP. And... Okay. So, 17 grams. C for water, I think, is 4.186 joules per gram. Degrees centigrade. Oh, lowercase t and q. Grams Celsius, yeah. Here, we'll put this as Q instead of E. Yeah, okay. Okay, and then the change in temperature, right? That's going to be from 100 minus 87.7, right? Because you got to go from here to here. So delta T is always final minus initial. Oh, the lower taste T is crazy? I don't know. I think T is... You don't like my lowercase t? Okay. All right, so that's the energy for, like, stage 1. Okay? Then we have stage 2, which is the vaporization. And I need to look that up. HVAP for water. Wait, these are two very different... Okay. 2260 joules per gram. Okay. So, Q, like, for it to vaporize is equal to 2260 joules per gram. And then we multiply that by the 17 grams. I see. Yeah, you're right. There's one for moles and one for mass. Okay. And then what specific heat of steam? 2.01? Cool. And then we have stage 3 when it's getting up to steam. And that's going to be 17, 2.01. And then that's going to be 121 minus 100. Right? Not too bad. All right, let's get the calculator out. See what we get. So we got 17 times 4.186 times was that 12.3? Good. Plus 2260 times 17. What's up, Rona? Plus 17 times 2.01 times 120 times 21. Nice. And you get about 40 kilojoules. Good job, Summer. Cool. That makes sense to you, yeah? You're very welcome, Summer. I'm glad. Okay, we're gonna post that in our Discord. That's question 10. Post. Nice. And so that'll go in. Let me save this. All right. Do a little bit of everything today. Some math, some physics, some chemistry. Everything is perfectly balanced, as it should be. All right, let's see. What do we have next? So I said, yeah, David, I can't do op amps. But maybe someone in my Discord can. I do have some electrical engineers that they probably know how to do it. I forget. Is Mathematic Fanatic an EE guy? Someone's an EE guy. Or maybe it was AFG was. And then post the ghosts in. Okay, so next question is from David. Looks like a related rates question. Sand is being poured on the ground, forming a growing heap which always maintains the shape of a cone. Cool. I'm going to write something I already know for the shape of a cone, right? Which is that V is equal to 1/3 pi r squared h.
Do you want to do this? Because I have it solved.
You already have it solved?
Yep.
Oh, okay. Let me is it hard? Let me just do because it's pretty fun, isn't it? This one's a fun one, right? Is it
Yeah.
It's not a pain, right?
No.
Okay. I appreciate it, yeah. Okay. Whose height is always equal to the radius of the base. This is beautiful. H always equals R. This is super easy. Okay. If the sand is falling at a rate of 0.2 meters cubed per second, how fast is the height of the heap increasing when the height is 50? This is great. I love these questions. Also, this is a warning. This is going to be 0.5 meters. You always want things to always be in the same units. So meters, centimeters, that's a no-no. No. Okay. Related rates. I always figure out what rate am I given. So I'm given the rate at which sand is falling on it. So that's the volume of sand in the cone. And that's dV/dt. That's equal to 0.2. And I'm asked to figure out how fast the height is increasing. So that's dH/dt. equals question mark. So once you have your two variables, which is v and h, I call them the rate variables. Now you just need an equation that relates these two things, which an equation that relates the velocity and the height of a cone is this. Unfortunately, this has another variable I don't want to deal with. You only want to have two variables in there. So I need some relationship between r and h, which I have right here. H is equal to r. So because of this, v is equal to 1/3 pi h cubed. Cool. So now I can take the derivative of this. And so the derivative of v is just 1. So I'm going to say that's just like dv dt. And then this becomes 3 times 1/3 pi h squared dh dt. So what we did is we took time derivatives of both sides. You can also do implicit differentiation and just divide by dt, but some people get mad at me in the math world for doing that. Thanks for the follow, Miles. Okay, cool. So now we're basically done because we know what dv dt is. We're going to solve for dh dt, and they want to do it when the height is equal to 0.5. So now you just say, like, okay, 0.2 is equal to 3 times 1/3 is just 1, so pi. And then this is 0.5 squared, and then this is dh dt. So, dh dt is equal to, what, this is 1/4. So multiply that over. So that's going to be, dividing by 1/4 is multiplying by 4. So this is going to be 0.8 pi. Is that what you got, Narosky, as well? 0.8 pi?
1 second.
Meters per second? I think is what I got.
Yeah.
Nice. Cool.
Wait,
Awesome.
0.8 pi?
0.8 pi. 0.8 divided by pi. Divided by pi.
Divided by pi. Yeah, divided
Yes.
by pi.
Thank you. Good call. Okay, there you go. That's a fun question. I love related rates. Somebody will ask me what my favorite topic in calculus is. I love related rates. I think related rates are dope. Thanks for the follow, Collarbones. Nice. That was David. All right, we're churning. We're churning. I want to get to do modes at least, because you did get recommended to me by my good friend Don. SP's next though. I don't understand math. I don't know why I came here. Do you want to understand math? So, little plug here. We have a math bootcamp course. It's pretty fun. If you want to go check it out. If you go to the website, actualofficehours.com, this is the beginner mode. You click here on math bootcamp. And this is a course we created. It's free. Totally free. Doesn't cost you any money. And it teaches you all the essential math things you need to know in order to, like, I would say, do basic high school stuff. I created this course because it's the same thing that I gave to my students at UCLA for the first week of lectures. I taught physics at UCLA. And coming into physics, I don't know, like, what level of math all the students know, because some of them came from high schools that didn't have calculus. Some of them came from high schools that just, like, stat padded and, like, they never learned math either. So, my first week of lecture was just, we're going to go over the basics. Like, I need to make sure you know how to work with exponents, fractions, algebraic expressions, some trig. It's all in there. So, yeah, go check it out. It's free. We made it. For you guys. The people. So, yeah. The link is... I think it's actually www.actualeducation.net/actualmath. I think that link works. Let me see if that link works. It does. Okay, so that link works as well. But also, if you go to the actualofficehours.com, it's under the math bootcamp thing. Go check it out. All right. SB, what do you got for me? Ooh, you got me some more Calc 3. I love the Calc 3, dude. We're doing so much Calc 3 today. Okay. Let M be the capped cylindrical surface, which is the union of two spheres. Wait, what? Oh, two surfaces, sorry. A cylinder and a hemispherical cap defined by that. Okay. A monstrous question. For z is greater than or equal to 1. For the vector field that compute curl f ds any way you like. Any way I like? Really? Oh, that's so nice of you, dude. I feel like I want to use Green's theorem here, or Stokes' theorem, which says that like the curl of f is equal to like the contour integral around it. Any way you want it, that's the way you like it. Or that's the way you need it. Isn't that how it works? You know? Yeah, no. Don't worry about this collarbone. Collarbone. This is really advanced calculus. Don't worry about this. Don't be scared. Don't be scared. Okay. X squared plus y squared is equal to 4. Cool. And then from 0 to 1, z. Okay, cool. Oh, wow. Look at this. They intersect, actually. That's boing. That's actually kind of cool. What was the link? Go to that website, actualofficehours.com. And then if you wanted the math boot camp, there's a button there for math boot camp. Okay, so this is like the cylinder. Right, and it's going up. And this is the cool thing. It's intersecting with a sphere that isn't centered also. This z minus 1, I think this is a clever design because the sphere is not centered at the origin. The sphere is like slightly below. I don't know. Jeff is gonna be horrified at this this sphere I'm trying to draw. Just pretend. Okay. And then we're trying to find curl f for like the whole surface. Okay. This is a beautiful example of where like I think I want to use the go around the thing instead of do the thing. Yes. Okay, where was that? I had it somewhere. Where's that equation sheet? I need that equation sheet, Morty. No. No, that was something else we did. There it is. That's what I want. Yup. Okay. Because, yeah, doing curl f, and that should be like dA. That would suck. Yes, no, it does. It contains absolute basics. Yeah, just like adding. Well, I don't know. Wait. What are absolute basics? Like, I assume you at least know how to add numbers. But like, for instance, it teaches you like how to add variables. And like some exponent rules that are important. I would say like if you're at least at an algebra level, it's great for you. Or if you're going into algebra, it's very useful. Algebra pre-calc, yeah. Even if you're in calculus, it's a great thing to refresh up on. Cause bro, I can't tell you like how many times like I forgot what like basic exponent rules were. Okay, I'm gonna use Stokes' theorem here. Reason being is this is a fucking ugly mess, but this is beautiful. Okay. So, we're gonna do... So, instead of doing the curl of f and dotting it with the surface area element, I'm gonna do the contour integral of f around a region that encloses it. And that is the intersection point. X squared plus y squared is equal to 4 at z is equal to 1. Right, because you see here how the hemisphere at z equals 1, we also get x squared plus y squared is equal to 4. This is super cool, actually. So I just need a contour integral of this, which is yuck, dot dr, and then it's around here. Okay, so I want to parameterize this, and here's what I'm going to say. I'm going to say that x is equal to r cosine theta, y is equal to r sine theta, and then that z is equal to 1 for that whole intersection point. Yeah, what's up, Shaq?
Yo, what's good, guys?
Good. What's going on?
I'm tired as hell. I just came back from work, so.
Nice, dude. I'm about to. Well, I'm technically working right now.
How long till the stream's
Arithmetic.
over?
Yeah, we got. Well, I got 30 minutes left.
Alright, I got 30 minutes worth of channel points.
Nice, go get it. Okay, so if R is, so this is like my R vector, which I'm gonna parameterize like going around in this circle. I now need to find dr, which means I'm gonna look at the derivative of this thing. And oh, here's the cool thing. R is constant, right? The radius is constant when I'm going around. So I just need this d theta. Yeah? I think. Yeah, I think this is just negative r sine theta, comma r cosine theta, comma 0, and then this is d theta. Right? Does that make sense? Because dr here, as we're going, so f dot dr is going to measure the amount of f, whatever f is, that points in the dr direction. And dr, it is not radius. It's like saying, like, as I'm going around here, that's pointing in just like the theta direction in cylindrical coordinates, right? So as we go around, this dr vector points in the theta hat direction. And that's actually kind of like why this makes sense. Okay, very cool. Is that good? Yeah. Well, it's like Green's theorem. It's called Stokes' theorem, technically. Okay, so, but now I need to make these substitutions in for here for f. So now f is equal to zx, so that's 1. So we'll say like r cosine theta plus 1 squared y, so plus r sine theta. Okay, so plus 8y, because, right, z is equal to 1. So y plus 7y is 8y, so that's plus 8r cosine theta. This one is just r sine theta cosine theta, or r squared sine theta cosine theta. And then this one is just r squared cosine squared theta. Yeah. Okay. And then I dot this, because, right, we have to integrate from 0 to 2 pi d theta, and then it's f dot dr, which is kind of a mess, honestly. Oh, wait. We have r cosine theta plus 8r cosine theta. Oh, beautiful, actually. Oh, no. This should have been sine theta. Oopsies. Should have been sine theta. Right. Yes. Let me just make sure that's right. Oh, and I forgot. Ooh, there's a 6x here. Forgot this one, sorry. Plus 6r cosine theta. Okay, I think we're good now. Okay, so when I dot these two, the cool thing here is, like, this will just cancel this out. So then we're just left with this. So let's see what we get. So we get 0 to 2 pi. And then that's going to be r... This is going to multiply with everything here. So that's going to be negative r squared sine theta cosine theta minus 8r squared sine squared theta. And then plus or minus r to the third sine squared theta cosine theta. Wait, mistake. Fuck. 1 second. I'm getting ahead of myself. This multiplies with this component. This multiplies with this component. It's cosine. Oh, okay. Well, it's still pretty close. Right, so minus 8 r squared sine squared theta. That's okay from this. And then this is plus r to the third. Let's make sure that was fine. Yeah, because I have an xy term. Okay. Plus r to the third sine theta cosine squared theta. This is just ugly, dude. Plus 6r squared cosine squared theta. Okay. D theta.
Good job.
Is this a nice integral? I don't feel like it is. I wish I had a sine squared and a cosine squared to like love each other, but this one's -8 and this one's +6. So this you'll convert to a double angle. I don't know how you're gonna do. Well, oh, this is u sub. You just say u is equal to cosine theta, and then these are just a pain in the ass to do. Okay. Do you want me to actually do those? Let me just put this in the chat. Actually, I want to see what chat would have done. I see like how to do it. I just don't know if I have the time to do all the integrals. Okay. Oh wait, no. Oh, sorry. That's not the question. Sorry, I need this question. Let's say, use that to solve this. I just want to see if there's any shortcut in the integrals. Yep. Yep. Wait, what? Thanks, dude. But M is a closed surface, and a closed surface has no boundary? Dude, what is this? What the shit? What is this saying? What are you saying, dude? Wait, what? No, wait, what? A boundary exists only if the surface is not closed. Joining two surfaces along a curve eliminates that curve from the boundary. Yes, they intersect. I got this. So the circle is an internal seam, not a this is where I don't know what's going on here. What? Cylinder has an open rim at z equals 1. The hemisphere also has an open rim at that same circle. When you glue them together, the rims cancel out. I agree. So the combined surface M is closed like a full capsule. Oh, okay. You know what I think we can maybe make the argument for? Is, what happens from 0 to 2 pi of these things.
Maybe ask Gemini.
What's up?
Maybe ask Gemini.
Yeah, okay. Instead of ChatGPT.
Yeah.
Yeah, let's ask Gemini. The answer is supposed to be -4 pi. Okay, let's see. You would think this. This also says the answer is 0.
Give it some thinking instead of fast.
Okay, thinking.
Like it's quick anyway.
Still to think. Still to think. Okay, the answer is supposed to be 4 pi. Oh, why did this reset again? Here, let me, I'm gonna ask ChatGPT to do this integral. Should be able to solve the integral. I just don't want to take the time to, like, go through and do all the fucking rules. Let's see if the answer is -4 pi from this. Let's see if we can read my handwriting. Oh, it's having trouble. Oh, dear. Oh, man. Okay, here we go. Let me see if I got it right. -r squared sine theta cosine theta minus 8r squared sine squared theta, right? Plus r to the third sine cosine squared theta plus 6r squared cosine squared theta. Correct? Cool. Evaluating 0 to pi. Yep. Yeah, it's going to start killing off the odd terms. Yeah, because the beautiful thing about 0 to 2 pi is, yeah, sine theta cosine theta goes to 0. And then sine theta cosine squared theta also goes to 0. Cool. So the final answer is negative 2 pi r squared. Okay, so whatever. This. Oh, I gotta reset this. That's actually really cool. I forgot about all the fun little cancellations you get. One sec. I think we're doing this the right way. It's called Group World. Group World. Get rid of the Q. Okay, so what they're saying is like over 0 to 2 pi. This is gonna go to 0. This is gonna go to 0. And then you're left with these two. Which cosine squared minus sine squared, I think is sine. Well, oh, but they have different coefficients on them, unfortunately. Yeah, here you go. Oh, but the integrals of sine squared from 0 to 2 pi is pi, and the other one is pi. Oh, this is so cool. Yeah, Group World. Oh, this is cool. So this is pi. This is pi on 0 to 2 pi. So you get negative 2 r squared pi. And then what was r equal to in this case? R is equal to, well, okay. At z equals 1, r is equal to 2. Shit. I get negative 8 pi. Oh. Alright, we're missing a 1/2 somewhere.
Surprise, motherfucker.
Where's the 1/2? Damn it. Man, I like my solution. I think I'm pretty good. Where did I mess up?
See if you like this. Like, I'm not qualified to check this, but I gave this to my guy.
Okay. Oh, it did Green's theorem. Oh.
I think it did both. Like, Stokes and Green's.
Yeah, this is valid too. Substitute z equals 0. Now, ooh, interesting. I don't think it exists in z equals 0. I think it exists in.
My grades up?
How do you keep?
He's
just really smart.
I don't. No, I don't. I usually just study in the last few months of school to bring them up.
Yeah, he just boss modes it. I think z equals 1. I think the intersection is at z equals 1. I don't agree that the intersection is at z equals 0.
I'm not qualified to check.
No, you're pretty well though. I mean, delta is the boundary. The boundary, yes, consists of cylinder walls. The only open edge is at the bottom of the cylinder? Wait, what did this question originally say? The capped cylindrical surface, which is the union of two surfaces. Oh, okay, wait a minute. Uh-huh. Okay. Yes, the cylinder walls from... Okay, I like this, actually. This is cool. And the top cap. The only open edge is at the bottom of the cylinder. Therefore, the boundary curve is x squared plus y squared equals to 4, lying in the plane z equals 0. Oh, okay. I think I see what's happening here. Okay, okay. Okay, so... I kind of had the shape right. Yeah, okay. I was close. So this is 1. And then you have this, like, cylindrical cap. Oh, sorry, this spherical cap on the top. I see. And so if you want to figure out f dot f, so curl f dA. So curl f dot dA. This is my issue. I thought this only referred to this as the area. And that's why I wanted to take the surface integral, so the contour integral around here. They want the whole surface, okay? So that includes the walls of the cylinder. So in fact, your contour integral has to be down here at z equals 0 instead of being up here. Does that make sense, SB? And then the right-hand rule makes sense because, you know, if you curl around that way, you know, curl is up. How does that take the cap into account? Yeah, you mean like versus it just being, like, let's say, for instance, it was just a cylinder. Oh, you know why? This is actually really cool, SB. This is very cool. Very cool. Very cool. Because the flux coming out of this surface is the same as the total flux coming out of the cap. That's what we talk about with closed surfaces, right? Yeah, that's really pretty, actually. So you're treating this as just a cylinder. The cap is like, whatever. Who gives a fuck about the cap? And then this is the only place that flux is coming in. Yeah, it makes sense, right? That's actually really cool. Okay. So, sorry. I should have done this at z equals 0. So, in fact, a lot of this actually goes away. This goes away. This goes away. And this goes away. Oh, man. So actually, we're just left with... Oh, and that's not going to be 8 anymore. That's going to be 7. Yeah, right? Because now I don't have one of the... Okay, this is now 7. Very cool. Okay, got it. Yes, it is a red herring. 100%. And thanks to Naroski with Gemini. Is that the pro version of Gemini, by the way? Did you pay for this version?
No, I have it free.
Yeah, I think I have it free too, right? Yeah.
Yeah.
Oh, okay. I'm thinking about starting to pay for Gemini because I do like it better. Dude, ChatGPT has been really fucking up recently. Yeah.
Bing bong.
Anyways, okay. So if this is -7, now -7 plus 6. I mean, the other rules still work, right? Whatever. This was 0 anyways. This was 0 anyways. This becomes -1r squared, which just then becomes -4 pi. Nice. Very cool. Very cool question.
That's dope.
Okay. I will do yours. Dumoed. We're gonna get it done. Thanks for that question, SB. That was cool. I am learning more and more and more about Calc 3. Dude, this whole quarter I feel like I've been taking Calc 3. just from the collective, like, some of my private students I tutor needed help in Calc 3, and I don't know, I feel like I've become the Calc 3 channel at this point, because I get so much Calc 3 asked. And it's fun, because I'm starting to finally getting a grasp on Calc 3. Calc 3 was my first class at college, in undergrad. It was a pretty tough one. Why is that not showing correctly? What's up, Machka?
Oh, yeah.
That white. Okay. Let me get do modes up. More things. Use algebraic integration. We're gonna do this is more Calc 3 actually, by the way. Basically. Okay. Show that the center of mass of a uniform solid hemisphere is 3/a from the center of the from the plane face. So center of mass in the x, y, and z component. So like x cm is the integral of x dm over the integral of dm, right? And then y cm is y, and then z is z, blah 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 blah. Okay, you may assume that the volume of the sphere is that, yeah. By symmetry in the x and y component, it's pretty easy to see that right, integrating this way and integrating this way is symmetric, so that's going to be 0. I think the question is, how far down in z do you need to go? And this is where I want to use cylindrical, but I know that's going to like screw something up. Okay. Because dm is going to be equal to rho dv. Okay. So integrating this way, this is just integral of rho dv, and dv for half a sphere is going to be 2/3. So it's 4/3 pi r cubed divided by 2. So that's going to be 4/6. So this is going to be rho times 2/3 pi r cubed, right? Okay, so that's the bottom part. We can say that xcm equals ycm equals 0 by symmetry. But let's figure out z. So z center mass is integral of z rho dv over rho 2/3 pi r cubed. Rho's are going to cancel. So it's just integral of z dv over 2/3 pi r cubed. Okay, so this is the interesting part. Rho dv. Z. Let's do this in spherical, I think. Yeah? Can we do this in spherical? So z is equal to... I'm going to do this in math land. Or is this physics land or math land? I think it's math land. So I'm gonna use phi. So I'm gonna say z is equal to r squared. No, it's r. Is it cosine theta? Yes, it's r cosine theta. That's what it is, I think. X equals to r. Oh, and we don't care about the other stuff. I think that's what it is. One second. Spherical. I'm trying to remember spherical coordinates. Yes. See, they use phi. Okay, it's phi. Okay, that's what it is. You always like... I always forget who likes phi polar. Yeah. It's math. Math is the one that likes this. And then I need to remember this. But it's like, fuck, which one is it?
Bruh.
No, it's phi. It's phi. Okay, R cosine phi. Yeah, this is what I want. Okay, this is it. And then this is R cosine phi. Okay, cool. So this is equal to the integral of R cosine phi, R squared sine phi, d phi, d theta, dr. This is me a triple integral. Then this is 2/3 pi r squared. Yeah, just sine polar, whichever one works. That's a big physics thing to do. You're just like, whatever, it just works. Okay, so r to the third, we can do that integral real quick because nothing else is going to depend on r. So that's just going to pull out 1/3. So we have 1/3 r cubed on the outside. And then we have integrals. Oh, and then we're going to pull a 2 pi from d theta. Okay, so let me just do what all the integrals would be. So this is going to be from like 0 to r. D theta is going to be 0 from 2 pi. Phi is going to go from pi over 2 to pi, right? I don't think it's negative pi to pi because we're only looking at half. We're only looking at half of a sphere, right? Because yeah, I think we're going from yeah, right? Yeah. Jeff says never mind. You're okay, Jeff. Lower half, yeah. Okay. Oh, it just erased all my shit, dude. No. All right, let me do these all out. Sorry. Dr, d theta, d phi. Dr goes from 0 to r. D theta goes from 0 to 2 pi. D phi goes from pi over 2 to pi. Just the first line, the Jacobian. Yes. Oh. Well, wait. This Jacobian is a 3x3 though. No, because I have r theta and phi. So you can't really parameterize it as well. I think you have to do dx dr, right? Dx d theta, dx d phi, and then you have to do like dy dr, dy d theta, dy d phi, and then dz dr, and then these are all the substitutions. And then I think you still take the determinant of that. It's a 3x3. What course is this? This is probably physics. But okay, these integrals are easy because this is going to pull out an r and a 2 pi. Okay. Well, and this is r to the third. Wait. We have r. Wait. Yeah, r cosine phi, r squared. Okay, so we have r to the third over 3. Wait, r to the fourth. Wait. Yeah, wait. Yeah, because z is r cosine theta, right? Okay. So I have r to the fourth over 3 times 2 pi. And then we have the integral from pi over 2 to pi of sine phi cosine phi d phi. This is 1/2 sine 2 phi. Is that right? Oh, it's cosine 2x. Wait. No. That's the derivative of it. Yeah, I want this one. Just fucking give it to me. Okay, there you go. Sine x cosine x is, yes, 1/2 sine 2x. I was right. Okay, cool. So then the integral of sine is going to be, that's going to be 1/4 minus 1/4 cosine 2 phi from pi over 2 to pi. Cosine of 2 pi is 1, so you get negative 1/4 times 1 minus cosine of pi is negative 1, so plus 1. So that equals negative 2/4, so negative 1/2. Cool. All right, so that's what the top part is. So it's well, that's what this part of the integral is. So then you have and then the 1/2 will kill off the 2 here. Oh man. All right, I have pi, negative pi over 3 r to the 4th over 2/3 pi r cubed. So that equals negative 1/2 r. Is that what we get? Yeah. But they wanted the answer to be 3/8. Shit. What do we do wrong here? What do we do wrong? Oh man. 4/3 pi r cubed is 2/3 pi r cubed. Z is r cosine phi, and then it's r squared sine phi d phi d theta d phi, yeah. And then sine x cosine x is, yeah. Oh, no, sorry, it's not 1/2. Wait, is it 1/2? Thank you, Norosky. Norosky here with the saving.
Made it so complicated.
I don't know why I made it so complicated.
Yeah.
Alright. I think I was just... He says, why do you make things? Because I just brute force things, because I'm American.
Like if you pick your axes correctly, this is nice.
Okay, let me see. So I don't know if... See, I always get weirded out whether you can do this. You're doing it cylindrical, basically, no?
Yeah, kind of.
Yeah, I always get weirded out if you're allowed to do that because of the curvature. Thickness
Well,
dx.
In this case, it's okay because x is a variable, right?
Okay.
So it varies between 0 and a. So if you can imagine the disks getting smaller.
Yes.
Right? So, yeah.
Yeah, okay. I get it. It's pi r squared, but then it's a squared minus x squared. But then, yeah, my question here is this dx. Are you allowed to do that?
I think so.
Dx is...
From the little bit I learned, yeah.
You're learning this is dx, right?
Yeah.
So there's some arguments against that because technically the thickness is curved.
I see. I suppose it becomes negligible if you bring them just closer enough.
It becomes something like this. I'm just saying, like, yeah, I get you did it in cylindrical. I think this sometimes fucks up, though. I guess maybe it worked this time. Yeah, it worked this time, but you gotta be careful.
I think this was intended because it became, like, way simpler.
Yeah.
Like, I saw what you were doing, I said, yeah, let me try.
You said no.
Oh, I think that's quite simple.
No, I like your way better. I want to know why I got this wrong, though. I'm fucking mad.
I'm not sure. I wasn't following, so...
No, you're okay, you're okay. One sec. Sine x cosine x... Wait, is equal to 1... Sorry, where's, like, the actual identity for this? Sine x cosine x, yeah, is 1/2 sine 2x. Glocks and Maris. Glocks and Maris. Integral of, yeah, is negative cosine. And then you gotta pull out another 1/2. That's why it's a quarter. How was I gonna get 3/8 though? Oh man. Oh wait. No. TR is r to the 4th. Oh, R the fourth over 4. What am I doing over 3? Dude, what? Oh my god. Oh my god, Geo, 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 Geo. Geo, what are you doing? Okay, there we go. I think this will maybe get me the right answer.
Oh, yeah, dude.
Disqualified.
Fucking fuck, dude. Yeah. Yeah, there we go. -3/8 R. I had it right, dude. Narosky, I just don't know how to fucking integrate sometimes. Okay. All right. We got that. Narosky solution I'm going to keep down there as well. This is also cool, but you got to be careful treating spherical things like cylinders. You got to just be careful. Be careful. It messes up sometimes. Okay, I figured it out. All right. I don't have time, sorry, for this part B. I'm going to leave this as an exercise. You did part B as well?
Yeah.
Oh, you did part B? Oh.
Yeah, I did it with vectors, like vectors of position.
Okay, I'm gonna post this in for you, Demo. I'm gonna post this in the Discord, and then Narosky will post his addition to part B. I appreciate that, yeah, because I'm running out of time. I really do gotta run to another student. Fuck.
Oh, you have
Okay.
another student?
I do. Well, yeah, I have to go drive to go teach another student outside of here.
Oh, okay.
Yeah. Okay. Cool. All right. That's it. Let's close out the stream. All right. Thank you, everyone, for coming to Actual Education Office Hours today. Sunday fun day. Big ups to all you guys in the crowd. Narosky, all you guys. I really appreciate learning from the audience. You guys are awesome. That's why I enjoy doing this. People are like, oh, man, it's so much work. I'm like, yes, it is work, but I also learn things from it, which I think is really cool. Love that. Oh, that's a very cool solution. I'll look through that at some point. Okay. Again, if we didn't get to your question, do not worry. They will still be added into the Discord from the queue. So make sure, go to the website, actualofficehours.com, and go check out the Join Our Discord button here, and then you'll see your questions get put into our Discord server. Also, check the streaming schedule to see all the different times we're streaming. We are not streaming tomorrow. Sorry, no streams on Monday. But I will probably add in an additional stream. Oh, did I already do it? Oh, I already added in an additional stream for you guys on Thursday. Look at that. Look how nice I am. Okay, so yeah, no stream on Monday, but I will be streaming again on Thursday, and then our next stream will be on Tuesday. So, again, website, go follow us on Twitch, go follow us on YouTube, all the platforms. We appreciate it. Helps out in the algorithm. If you're following us on Twitch right now, we're going to go raid someone. This is the awesome thing about Twitch. YouTube hasn't built this in yet. I can't raid channels on YouTube. So let's see who's on right now. Who are we gonna go say hi to? Physics and Depression. I like Physics and Depression. He's cool. If you got more physics questions, go say hi to Physics and Depression for us. If you want to go learn some physics, he's an awesome guy. Looks like he's doing looks like Lagrangians maybe. Yeah, cool. Okay. Enjoy the rest of your Sunday. Enjoy the weekend. We will see you on Tuesday. Peace. All right. Peace, Narosky. Peace, guys.
Thanks.
Denali Dice, hello, welcome. Yeah, actually, there's I don't know if you've used LaTeX, but there was there's some kind of extension for LaTeX or something like that, where it sort of homogenizes